A very good afternoon, one and all. I welcome you all for this session at the venue all day, all night. The topics under this session would be foundations and deep excavations. I would be coordinating this session. It's my pleasure to welcome our chair for this session, Dr. P. Hariprasad Reddy, Professor, Department of Civil Engineering, NIT Warangal. He's done his PhD from IISc Bangalore. His areas of research interests are geo-environmental engineering, solid waste management, water and wastewater treatments. I also take this opportunity to welcome our co-chair, Shabana, Assistant Vice President, Strata Geosynthetics. She's done her MTech in geotechnical engineering, and with her 23 years of vast experience in geosynthetics, she would be the co-chair for this session. Now I request our chair, Professor Hariprasad Reddy sir, to please preside.
Thank you, Vishwajit. Thank you, Vishwajit. Good afternoon, everyone. I welcome you all to this technical session on foundation and deep excavation. So here we have one invited speaker and around 7 contributing presentations are there, in which 5 authors have turned up so far. So if all the authors are here, then we'll be giving 8 minutes of time for the presentation and 2 minutes for discussion. So the theme speaker will be presenting for 15 minutes, and we can have a couple of questions after that. So without much delay, we'll start the session. Now I invite Professor Benson Sheng from National Cheng Sheng University, Taiwan. So he'll be presenting on impacts from consolidation caused by deep excavation in clays in Jakarta, Indonesia. So I briefly introduce the professor. Dr. Benson got his PhD from University of Bristol in the UK, and then moved to London to work for several large-scale infrastructure projects in both the UK and Taiwan. He went back to Taiwan in August 2003 to join the university. His main research activities are deep excavations and soft ground tunneling. Simultaneously, he is also involved in some underground and offshore wind projects as a technical consultant or advisor. Dr. Sheng is a well-qualified British chartered civil engineer. He is the chair of ASRTC 6, as well as a member of TC 204 and TC 305 of ISSMG. Currently working for the Department of Civil Engineering of National Cheng Sheng University in Taichung, Taiwan. So I welcome you, sir.
Thank you. Yeah, yes. This one. Yeah.
Light change and point.
Okay. Yeah. Thanks for the chairman's introduction. And this is my 5th time to India, and first time in Goa. And I think it's an honor for me to be invited as an invited speaker to give a presentation today. And although today I'm going to talk about excavation in Jakarta, but I did work for Delhi Metro before. That's Delhi Metro Phase 2 underground package. Okay. So today my presentation topic is this one: the impact from the consolidation caused by deep excavation in clay in Jakarta, Indonesia. And I will recognize this paper as a follow-up of a journal paper which we published in 2023. And I will have 4 parts of my presentation. The first part is about the introduction, and the second part is talking about the FE modeling which we used, and then will be the result and the discussion. And last hour we will make a short conclusion. Okay, talking about excavation, as I mentioned, I know if I don't use microphone, can you all hear me? Yes. Yeah. Okay. Yeah, that's good. Okay. Just like I mentioned here, for deep excavation, top-down method is a method which one of the methods quite popular to be used. But it demands a significant, use this one. Okay. Oh, okay. Yeah, because I prefer two hands.
It's a pocket.
Okay, sure.
It's in the pocket.
Okay.
And this in
So I should put this
the pocket.
in the pocket. Here?
There.
Oh, here.
Okay.
Yeah. Okay. For the top-down method, because we normally has to use RC slab as a horizontal support, so it take a longer time. So that's the reason why I talk about I say amount of time to construct the excavation because we need the RC slab as a horizontal support. And diagonal wall can experience a substantial deformation during the waiting period because the casting time is longer. So really, we may have more deformations of the D wall, and both consolidation and creep, so-called time-dependent behaviors, play a significant role in the phenomena. So that's the reason why we want to talk about the time-dependent behavior things. And previous research, for example, like in 2019, Harald and Professor O in 2020, and Lim in 2003, and Deng et al. 2023. They all talk about the time-dependent behavior caused by the deep excavation, and it also say, time-dependent could enhance more wall deformations there. And that's the reason why we intend to do some research about time-dependent behavior of the excavation in Jakarta is still limited. Because I will explain why we want to talk about excavation in Jakarta later on. But as far as we know, the study for that is very limited. And that's the previous study I talked about, the paper which we published in a journal in 2023. We use 3D FEM analysis. Actually, that's places use Jakarta as a background, and also we use a model which you can consider time-dependent behavior, like the soft soil or even soft soil creep, in order to understand what happens, for the deformation caused by the top-down excavation. And it is suggested the soil parameter obtained from the lab calibration were not significantly reliable. I will explain that in my next two slides. And lack of dependent result from the construction test introduced the major the uncertainty because we don't have a reliable SI data, so it has uncertainties for the effect of time dependent. So that's a background for us why we want to do this study and try to get some conclusions. Okay, now talking about the uncertainty of the soils, which we have here. This is a figure which we have, because we use the underground work in Jakarta MRT excavation as a background. As you can see, these assays show the undulation strength, and these assays show the SPDN value. This shows the SPDN value. And you can see the data actually quite scattered there. So you even cannot have a kind of relationship between the SU and the SPDN value. And we try to explore why, because supposedly if you understand from the statement made by Professor Skemter, it should have. So we look at the data which we have, the so-called SQD, sample quality destination, recommended by Professor Tazaki and Professor Pak to evaluate so-called sample qualities. And in fact, by the volumetric strength which you have from the sample, you understand in the most of the samples which we have are in level C, D, E. But actually, Professor Tazaki and Pak say, if you want to do the undisturbed sample, you need to keep level in A and B. So that's one of the reasons why I say, maybe our test data is not that reliable. So, and again, if you look at this is a sampler, a thin wall sampler. Suppose the tap here should be rounded, but as you can see, that's totally twisted. And let's they use that to do the sampling work. So from these two, we understand, say, our sample are kind of disturbed. So and also we look at the CPD result and understand actually say deeper than like maybe 8 meters below surface ground level, the soil actually quite stiff. So this gives us a kind of confidence, say, oh, we have to do more tests together with CPD to get more reliable test data. That's what the site condition have. And very special thing is, even though that's in Jakarta, funded by Japanese government, but we, as a company or engineers from Taiwan, we have a chance to be involved in this project. So that's the reason why when we have the first tunnel breakthrough, we have our national flag there. Okay. Here comes to the last page of my presentation. So that's some conclusion which we got here, because we do find some sand layers between very thick clay. So that's the reason why we have a need to evaluate what the consolidation and even the creep, affect the deformations. And we in fact, we understand from the simulation which we have, we did point out, say, consolidation actually is quite an important factors, for the deep excavation in Jakarta using the top-down method. But as I just mentioned, we do have some uncertainties about no matter the time-dependent soil parameters like a compression index or even the swaying index or like the creep index, and even the construction time of the slab. So we want to explore, those parameters individually one by one. So here talking about the FE models which we have here. We use software process and do the two-dimensional analysis, and that's the case. That's a profile excavation profile together with the soil which we have here, and as you can see, that's excavation down to like a 24 something below surface level, but the wall actually is not that deep. It's up to 33 meters, because as I just mentioned, going down, further down to 8 meters below surface level, the soil is quite stiff. And the same excavation profile we use for the 2023, so that's the reason why I say that's a follow-up. And we did have embankments nearby, so we have to consider what the impact from the consolidation. Okay, so very quickly further explain the FE models which we have. So we again use soft soil creep models. But just like I mentioned, in SSC, here lists all the parameters which you have to use there. And just like I mentioned, the consolidation parameters here, what we include have the compression index and even the swaying index, and also the creep index, and we use a uniform very fine mesh in our analysis, and a value of 0.7 we use for the R-inter, and this is the construction phase which we assume in our analysis, and that's the structural parameters basically used for the retaining wall and also for the RC slab in our model. Okay, now we want to explore the parameters one by one. Sorry, how much time I have now? Another 5 minutes, okay. So I have to be quick. Okay, so we want to explore the parameters one by one. Okay, so the first one we evaluate is the so-called compression index. So if you look at the result here, this is a ratio show you what the maximum wall deflection is divided by the h. Okay, and here we try to change the compression index there. So as you can see there, actually the line here is quite straight, quite flat. So it means the compression index may not give once you change the compression index, may not give you a very significant change for the wall deformations. So it means even though we don't have a confidence about the compression index, it should be fine because it doesn't change a lot. So that's the first conclusions which we have from the compression index. And second one is about we talk about the swaying index. Okay, y-axis is the same with the compression index, and here we change to R bar. Yes, that's a swaying index. But you can see swaying index actually give more changes. If you have different values of the swaying index. So looks like the uncertainty of swaying index can lead a more significant change of the maximum wall displacement, which we based on our testing. So that's what we have for the second parametric study. And the last one is about the creep index. Again, we try to put in the figures here. So the same ratio, I mean the maximum wall displacement divided by the excavation, and that's the creep index. And in fact, if you have a creep index less than 0.012, and that's no significant change there. But once you have a value more than that, and then it will affect more. So for this index, I think we will need more explorations. I mean, to confirm what the value will be. I mean, by like a laboratory testing to understand what the creep index will be. And the last one is the construction time. So our understanding is the construction time. If you have some time longer, indeed, I mean, you are going to have more displacement rather than the original one. So construction time really is the issue. So here I come to the conclusion. Very quick, just like I say, the compression index doesn't significantly affect the result, but shredding index it does affect a lot. It does affect a lot. So really, you will have to consider what the real shredding, get the more reliable one. And the creep index, as I just mentioned, as long as you have a value more than 0.012, and it is going to affect more. So more reliable testing about the creep has to be done, and also the construction time is also an issue to affect the maximum wall displacement. Okay, that's the end of my presentation. Thank you very much. Yeah.
Having any questions, you can ask to the speaker. Yes.
Thank you, Professor Benson.
Thank you.
I was just wondering, when you simulate the wall deformation, how did the pore pressure work? Because it's saturated, right?
Yeah.
And you're talking about consolidation.
Yeah,
so
yeah.
How was the pore pressure response?
We actually, I think we actually let me think about, because we actually try to compare the pore pressure and I think we do have a kind of during the consolidation time we do have a kind of dissipation of the pore pressure.
Yes.
Yeah.
At the same time, as evident from your results, since this is an unloading problem, correct? So we really, to start with, we don't expect CC to make much of a difference. And that way, the more than consolidation, it's kind of a swelling or like expansive unloading behavior. So I was just wondering, did you notice any negative generation of excess pore pressure, or like which way was it dissipating? Was it more of a consolidation or deformation problem, or a flow problem when water is coming out, a seepage problem?
Well, okay. I think that's a very good question. Because in fact, in this paper, we actually pay more attention about the wall deformation instead of pore pressure. Yeah, because the issue is we don't have the piezometers. What we have is only the observation well. So really, you cannot get it what the real pore pressure will be. But by the papers we published in 2023, we think consolidation play a more critical role rather than creep, because based on the portion of the consolidation which we have from the analysis. So what I can tell you is that based on our analytical result, we can tell you is consolidation may play more critical role, because it is about like almost 30% of the deformation, the total deformations. But in reality, I think we still need to explore more later on. Yeah, thank you.
Thank you.
Thank you,
Professor.
Yeah.
Any more questions? So if no more questions, I thank the speaker,
Thank you.
Professor Benson,
Thank
for
you. Thank you very
taking
much.
the time.
Thank you.
So, as a token of
request-
appreciation,
Yeah.
so we request you to take them.
Yeah. Thank you. Yeah. So can you use? Thank you very much. Thank you.
The speaker is busy with another meeting. I think he's leaving. So we'll continue the session.
Sorry, because I need to join the council meeting, annual council meeting. So thank you very much. Thank you.
So now I hand over the session to our co-chair to continue the proceedings.
Thank you, sir. Good afternoon, everyone. Let's call for our first presenter, Assessment of Gravel Soils in Bridge Foundation Construction using X-rays, CT analysis, and density log. I would like request author to come and present. Thank you.
I request to take 7 to 8 minutes for presentation.
Yes, okay. My name is Kota Wakinaka from National Institute of Technology Kumamoto College in Japan, and I'm going to have a presentation on this topic. And this is contents of my presentation. And first of all, introduction and research background. And in Japan, the standard penetration test is recognized as the representative investigation method. However, since the test is conducted at 1 meter intervals, so it is difficult to identify localized weak soil zones. Furthermore, relying on N values to derive various soil properties for structural design is inappropriate. So this study aimed to identify bearing stratum prior to bridge foundation construction using N-various X-ray CT analysis of boring cores and density log. X-ray CT analysis was used to estimate core density, and the accuracy of the density values was assessed with density log results. Based on density, we attempt to evaluate the bearing stratum, and the results are reported here. And next, survey site and survey method. This study area includes river bridge located within Kumamoto Prefecture, Japan, and the stratigraphic composition is shown in this table. The fourth layer is the bearing stratum, and consisting of a sandy gravel layer with cobbles, showing N values greater than 50. However, in the upper part, a slightly loose gravel layer is distributed. Therefore, careful attention is required to accurately identify the bearing strata. And next, survey method. In this investigation, we attempt to reliably identify irregular soft zones within the bearing stratum using X-ray CT analysis and density log. Observations of boring cores shows that the gravel content on the core surface does not always correspond to the interior. Therefore, X-ray CT images were used to visualize the interior of the cores. Furthermore, CT values were used with the aim of countability representing the visualized core interior. CT image always was performed on slices at 1 centimeter intervals, and the average CT value within each cross-section was calculated. The CT value were converted to electron density using a correlation based on actual density test results. In addition, the conversion from electron density to physical density was calculated from this formula by Electra company. And next, survey results. This figure shows the depth distribution of density values obtained from X-ray CT and the density log. The terrace deposit layer, which serves as the bearing stratum, has been identified from depth of 30.82 meter from here. So these are shown terrace depository areas. And although there is generally a strong correlation between the densities obtained from X-ray CT analysis and the density log, some localized deviations are present with the density log tending to show lower values. This is particularly evident in the upper terrace deposit within this section. This discrepancy is considered to be largely influenced by the lack of close contact between the casing pipes and the borehole ore. We conducted the density log with the casing pipes. However, when the gravel is small or the substrate is rude, the gravel moves easily and cannot be excavated properly. In such cases, a void is formed between the casing pipe and the borehole wall due to the irregularities of the borehole wall. On the other hand, the densities between these depths exhibit a strong correlation trend. We have confirmed from the observation of the borehole core that it is a clay layer. So, of course, no gravel. It is considered that there was little no gap between the casing pipe and the borehole wall. As a result, the correlation with density exhibits a clear trend. This can also be considered supporting data for the hypothesis that the density discrepancy is due to a lack of close contact between the casing perimeter and the borehole. And next, this figure shows N values at two representative locations and the evaluation of the bearing stratum. For number 2, since the N value remains below 50, even within the terrace deposit layer, the bearing stratum is evaluated from 34 meters. For number 1, the N value reaches 50 immediately upon the entering the terrace deposit layer, indicating that based solely on the N value, the upper part of the terrace deposit layer can be considered suitable as the bearing stratum. However, number 1 corresponds to the location where the density values were previously shown, and the upper part above the measured density may consist of small gravel or looser matrix. Therefore, since the upper part may be loose due to redeposition, the bearing stratum is evaluated at the depths near 32.2 meter, where the discrepancy between the two density values becomes very minimal. And next, I will discuss the correlation between the density values obtained from X-ray CT analysis and the converted N values. In the terrace deposit layer, which serves as the bearing stratum, the converted N value exceeds 50, whereas in the former riverbed deposits, it remains below 50. It generally shows a tendency for N values to exceed 50 when the density is greater than approximately 2.3, suggesting that density can serve as one of the indicators for evaluating the bearing stratum. And last conclusion, we conducted the bearing stratum evaluation not only based on N value, but also using X-ray CT analysis and density log, with the aim of relatively identifying the bearing stratum. As a result, these conclusions were obtained. Thank you. Thank you for your attention.
Thank you so much. Any questions? No questions? Thank you so much.
Okay, thank you. Thank you so much.
Our next topic is thermal performance of a geothermal pile group in the presence of coupled thermo-hydroflow condition in layered soil. Mr. Arvind Kumar.
This one, right?
So good afternoon, everyone. So I'm going to present thermal performance of geothermal pile in a group and presence of coupled tiers flow condition in layered ground. So I'm using my current designation, but most of these works were done during my PhD at IIT Bombay with Professor Prasenjit Basu. So it's there. So if we talk about geothermal energy, most of the time we think that a deep geothermal energy where temperature goes beyond 100 degree and we produce electricity. But when we talk about shallow geothermal energy, it's mostly on the upper layer of the soil up to 300 to 400 meter, and then temperature is almost constant after 5 to 6 meter depending on the geographical location. And we can utilize these potentials because when we change the weather, we see that in summer and winter temperature on the surface very, very differently. But beneath our feet, it's constant. We can utilize this potential to heat or cool our building depending on our demand. And that's the part of this research. So why we choose shallow geothermal energy over conventional heating and cooling method? Because we see that we already in this building in a cool environment and it's running on the air source heat pump most probably. So why we need shallow geothermal energy? It's because it's very sustainable, it's economical, and it's energy efficient. We call it renewable energy, so we are not burning our coal or not utilizing low efficiency electricity demand, so we can save a lot when we utilize shallow geothermal energy, and that's why it is important to investigate this topic. And it's not that it's happening for the first time because it's using from 1950, but thoroughly over the research, we investigate this topic, and then we have come to a more refining technology so we can improve its coefficient of performance even further. So if we talk about the heat transfer in the soil, because it's not a very core topic to the geotechnical engineering, so it's important to discuss. So we have 4 important mode of the heat transfer. Start with the conduction, advection, that heat transfers with the flow of any media like groundwater flow. And then we have convection, where heat transfers within the fluid itself because of the temperature gradient, and radiation, that is not much important of the geotechnical engineering. So how does this process influence the soil? If we discuss, we have on the coarse grained soil, consider either pebble or coarse grained sand, and how does heat transfer influence in coarse grained soil? That if you have very high hydraulic conductivity, it will be a drained process and it will change the thermal property of the soil. In terms of fine grained soil, it's not having a high hydraulic conductivity, very low hydraulic conductivity. So when we increase the temperature of the fine grained soil, what we will do that it will generate pore water pressure. Because if we heat the pore pressure, a pore fluid, it will try to expand. And if try to expand and there is no space to get out that water, then it will try to generate the pore water pressure. Once pore water pressure is generated, what will happen that it will try to dissipate over the time, and then until it's not dissipated, you get the undrained response, and once it is dissipated, you get the thermal consolidation and then deformation. So this whole process, it have 3 major components when it comes to geotechnical engineering: that thermal, hydraulic, and mechanical. When we talk about the deep foundation and where there is temperature is involved, we have to investigate this THM that we call famously thermo-hydromechanical coupling that influence the pile capacity and then soil-pile interaction on the surface. But for this presentation, I will mostly focus on the thermo-hydro coupling, that how temperature and hydraulic component is going to influence the process. So if we talk about a little bit mathematics here we see that the standard heat transfer equation in a porous media, where we have heat storage component, where we have fluid flow component, and then how heat transfer happens because of the thermal conductivity. And this is a Brinkmann equation. I am not going to detail of this equation, but how these 2 equations are coupled to effect of the thermal and hydraulic both. So if we look at here is a time dependent change in the temperature, del T over del T. And then because we have a thermal gradient here, what happens that density of the pore fluid changes in the medium. And that density driven flow creates a force, a volume force in a media, in a fluid, and that triggers a velocity here. Now once this velocity is triggered, what will happen that this velocity will activate this component. So by two-way coupling, the heat transfer and fluid flow both influence each other, and this process becomes a highly, you can say, non-linear process. So as we discussed earlier here, we can see the plot that how temperature changes in the ground over the summer or winter throughout the season and after a couple of days. So this depends on season to place to place, and after approximately 5 to 8 meters, it's almost constant. On the surface, there is a large temperature variation, and we can utilize this potential. In summer, we can extract heat from the building, send into the ground, so we can cool our building like we are seeing here. In winter, it's exactly opposite. So when environment is at the colder temperature, we can extract heat from the ground and then heat our building. That's how we utilize halogeo-thermal energy. And in terms of energy pile, why energy pile? Because for this, anyway, to sustain a building structure, we are installing pile. We can install geothermal heat exchanger in the pile and then utilize this process without any additional cost of borehole or any other medium. So when we install geothermal pile, the geothermal heat exchangers can be of a many shape and size depending on the pile diameter and need. So it can be a single U-loop here, as I explained. It can be double U-loop. It can be a multiple U-loop depending on the diameter of the pile. If it is a very big diameter like 1 meter, 2 meter, we can have 3 or 4 loop. Depending on the design, it can be coaxial as well, where you send the fluid from the center and then take it from the up. And when we want to install a large amount of the loop, we use a helical tube as well. So depending on the design, this may vary. Now, for this study, we took an example of 3 piles group at different spacing, and then there was a clay layer and a sand layer, and then sand layer is of course having high hydraulic conductivity. So we thought that how the natural convection process is going to affect the entire heat transfer process in this medium. We use finite element software for this design, and here we can see that the influence here, that how it affects that. In the sand layer, heat transfer is happening very fast compared to the clay layer. So initially, when natural convection is not triggered, you can see that the process is almost same in the both in initial portion now, but as time process, what happens that in the sand layer, you have a very high thermal expansion. And when we look at heat transfer or thermal temperature contour, when we consider only conduction, when we are not considering the coupling of thermomechanical process, thermohydro process, TH process, then we see that temperature is evenly distributed in both the layer, because we are not considering the hydraulic component. But when we consider the hydraulic component, here we see that in the sand layer, temperature is very narrowly, because most of the temperatures are getting dissipated far away because of the natural convection. But in case of conduction, all the temperatures are close to pi.
We have 2 minutes, Arvind.
Okay. And then when we investigated the heat storage capacity, we can see that the process of coupled flow is always enabled to store more energy depending on the pile spacing. Mostly in a group, we have pile at a small space, and we can see that when the space is 2.5 D, and in case of 3 active piles, we can store almost 60% more heat in that, or in terms of extraction, it will be the same. So if we compare the whole group system, that how the process is happening, that if we have just 2 active pile or 3 active pile at different spacing, and we compare with a single pile, we can see that in terms of conduction and natural convection for the single pile, this is 10.17%. But in terms of 3 pile, and especially as the close spacing pile, this increased to 30%. So this shows that when we model it with the proper physics that is happening in the ground, we can extract more and more amount of energy. So with that, we conclude that natural convection do influence the heat transfer process, and it affects our energy extraction and energy injection capacity. So when we design our geothermal pile, we should not design based on just conduction, because then we assume that the entire pile is increasing with the same temperature. But we saw that in process, it's not happening. When we have a layer of coarse grained soil where our hydraulic conductivity is more, we see that temperature increase is less, and this temperature difference between the section of the pile will influence the pile integrity and its bearing capacity of the pile as well. So we have to be very careful when we design with the different layer of the soil. So thank you, that's all from me.
Very nice presentation.
Thank you very much.
Anyone, any questions?
Yeah, what is the temperatures that you are talking here?
So here we consider the ground temperature is 22 degree, and then the inlet temperature was 40 degree.
Okay.
So it was mostly simulating the Indian condition that we have a hot summer and we want to cool the building. So we take inlet as the high temperature we take from the building, and then ground, because ground is at lower temperature, 22 degree, the heat we get is lower than the 40, and we utilize this to cool the building.
Okay.
In winter it will be exactly opposite.
So this is basically numerical study, or you have any
This is the
field data you are...
This is the numerical study, but now where I am doing my postdoc, where we are doing in the field as well.
Okay. Thank you.
Thank you very much.
Anywhere we are doing it in real life project, these things in
Yeah,
India.
yes, we are doing it real life. I believe that we always talk with professors that why we are not doing in India. We are doing it in Europe, we are doing in China, we are doing in Australia, USA, almost everywhere except India.
Thank you so much.
Thank you very much.
We'll go for the next topic, non-destructive evaluation for the integrity of geostructures based on electromagnetic waves. Is not here? Okay. Later. Okay, sir. So we'll go for the next one, forensic geotechnical analysis of sinking of large concrete slurry tank.
I am here to present my paper, Forensic Geotechnical Analysis of Sinking of Large Concrete Slurry Tanks. Coming to the introduction, forensic geotechnical engineering deals with the reasons for non-compliance performance of constructed facilities. It analyzes the contributory and triggering factors that may have led to the undesired incident. Now, coming to the problem, we have two slurry storage tanks that were constructed in 2021. It is 15-meter internal diameter and 15-meter in height. The clear distance between these two tanks was 1.3 meter, and the tank walls were 1 meter thick, made of concrete. Both these slurry tanks are continuously sinking since commission. So the total and differential settlement in 12 months, the tank 1 has settled by 628 mm with a tilt recorded 1 in 30, and tank 2 by 734 mm with a tilt of 1 in 20. And the allowable limit of differential settlement is 1 in 500 as per IS 1904 2021. So these tilts are very high. So this was the tank that was tilting, and this was a plumb bob arrangement to measure the tilt of this tank. Now coming to the soil underneath, it has got a top fill material. It was followed by a thick layer of greyish soft clay soil. Beneath the clay strata, there existed moderately weathered to slightly weathered amygdoidal basalt rock. However, few boreholes drilled near the concerned location showed the presence of highly weathered and fragmented rock as well. Coming to the foundation details, the proposed foundation actually consisted of a pile group connected to a raft, which acted as the base for the slurry storage tank. Each tank was supported by a group of 97 piles in circular pattern, and diameter of these piles was 0.6 meter with a center-to-center radial spacing that varied from 1.5 to 2 meters. So this was the arrangement of piles, the 97 piles in concentric circular pattern, and minimum spacing was around 2.5 D, and the embedment length of the piles varied from 21.2 meters to 25.2 meters depending upon the availability of competent rock strata, and all the piles were socketed to a depth of about 1.2 meter. That's about 2 times the pile dia, 0.6 meter. Coming to the numerical investigation that was done to perform this forensic analysis, it was done in Plaxis 3D, latest version. The soil stratigraphy was divided into 3 layers. So we have the top fill material from 0 to 1.5 meter, and then soft clay soil from 1.5 to 22 meter, and then medium gray basalt rock that was extended to 30 meters. The constitutive model for the fill and rock layer was Moore Coulomb model, and soft soil model was used to represent the behavior of the sandwich clay layer, which was exhibiting a high degree of compressibility. In fact, the compression index was around 2.37, and pile group was modeled using an array of elastic embedded beams. Maximum value of the skin friction resistance and base resistance has been entered as a part of embedded beam property. Now the raft was modeled as an elastic plate with a thickness of 3 meter and modulus of velocity of 30 gigapascal, which is a value for the concrete. And connection between the pile and the raft was set to rigid in the present investigation. And the total static load that was coming, including the self-weight and the weight of the filled slurry, was around 6,689 tons. And if we calculate the surface load intensity, dividing it with the area, it will come around 289 kilopascal. So this is the finite element model in structures mode, where just you can see the raft and the connected piles, 97 piles, and the superimposed load of 289 kilopascal. So these were the properties of the soil: filled up soil, grace clay soil, and basalt rock. And we can see for the clay soil, it had a cohesion of 40 kilopascals and friction angle of 3 degrees for a huge thickness. Now coming to the results and discussion, if you see the effect of rock quality condition, the average of RQD and core recovery was around 70%. Now if we calculate the ultimate bearing capacity of this rock socketed pile based on IRC 78/2014, it will come around 4,483 kilonewton. Sorry, it is kilonewton. And however, in few boreholes located closer to the tank area, the rock quality designation and the core recovery values are very low. In fact, RQD plus core recovery by 2 will come less than 30%. In such a case of fragmented rock material, based on IRC 78/2014, the magnitude of ultimate bearing capacity was obtained just as 2,912 kilonewton. So, from the current numerical investigation, we have found that the maximum axial force developed at the pile base is around 780 kilonewton. So based on that, we can understand that the factor of safety was around 5.7 initially, but if poor rock quality conditions existed at the pile base, it would have reduced to 2.4. Now coming to the effect of downward drag forces. So for this, the numerical analysis was conducted with a consolidation calculation, where the soft layer was allowed to consolidate for a period of 365 days. Axial force at the pile tip was found to increase from 780 kilonewton to 996 kilonewton. And this would affect the factor of safety. The factor of safety would go down now from 5.7 to 4.5 in case there is a good quality rock. But in case if the rock quality was much lesser, as RQD and core recovery by 2 is less than 30, as was the case in some boreholes, it would come as low as 1.9, considering the combined effect of downward drag and the existence of very poor rock condition. Although the failure risk may be substantiated with a highly reduced factor of safety, it does not explain the cause of failure, because still the factor of safety is greater than 1, and the settlements were around 50 to 60 mm only. Now, another possibility could be that the pile is terminated on soft clay. High magnitude of total and differential settlement may not occur even if pile was terminated in very weak fragmented rock zone. In this scenario, it is suspected that the pile was terminated in a much softer material with comparatively lower stiffness and strength. Distinction between the rock and the soil at the site was just based on specific gravity. In fact, something greater than 2.7 was classified as rock. However, specific gravity is not a proper indicator of the strength. Hence, a numerical investigation was conducted by extending the soft clay layer to 30 meters. Hence, the simulation represented the case of a floating pile surrounded by a consolidating soft clay layer. Now, results from the consolidation analysis revealed the total and differential settlement of the pile raft foundation. The maximum settlement and minimum were around 701 mm and 471 mm. This was very close to the maximum settlement observed at the site, which was around 628 mm and 734 mm. However, the tilt obtained in the present analysis is about 1 in 80. This was much lesser than the reported value of 1 in 20 and 1 in 30. This may be attributed to the very rigid connection that was assumed in the FE model between the pile and the raft. Also, the raft-soil interaction was not modeled accurately in the analysis, as it may be concluded that there is a high probability that most of the piles are founded on soft compressible clay strata. Finally so this is the picture finally where you can see the deformed mesh, and due to the consolidation and due to the overlapping of the pressure bulb, this is the way the tank was getting subsided. Coming to the conclusions, presence of a highly weathered and fragmented rock deposit reduces the factor of safety drastically from 5.7 to 2.4, and the downward drag on the pile is found to reduce factor of safety further from 5.7 and 2.4 to 4.5 and 1.9 respectively, considering the moderately weathered and highly fragmented rock deposits. And the analysis also reveals that there is a high probability of piles being terminated on soft compressible clay strata, leading to heavy settlements. That's all from me. Thank you.
Any questions?
So, thank you for the presentation. Water table where you have considered?
It was 1 meter below the ground level.
1 meter below?
Yes. It was actually, the site was near Mumbai region only.
Okay.
So they told me the details were given. Pretty But we didn't have the SPT N value under the proposed site. It was a large area. They had many boreholes, SPT values were given. So it was given 1 meter below the ground level. So I had considered like that.
But your raft thickness was 3 meter, no?
Raft was?
Pile cap thickness.
Pile cap thickness was, it was, the tank wall was 1 meter. Pile raft thickness was 2 meter.
Mentioned 3 meter. So
Okay, maybe 2.
pile and pile cap both are floating. You have taken floating pole.
Means you are asking there is 0 to 1.5 meter, there is a fill material. Below
Yes,
that
okay.
only.
Okay,
Below
thank you.
that there is a thick clay layer.
What is the proposed solution? Now now it is settling, right?
And this may be a problem of inadequate soil investigation only, but we could have done some sleeving on the piles to reduce the negative skin friction in case if it was due to negative skin friction. Sleeving on the pile to reduce this negative skin friction issues.
Instead of socket of 1.2 meter,
Oh,
there was a socket of 1.2 meter for the piling of what you have shown there. But I am little bit surprised that you're telling there was a soft soil, and then when the adjacent bore log was having some weathered rock, right? And because of that, all these kind of an axial forces have increased on the pile. Because the pile is 97, it's a huge amount. And the depth is huge, like 22 meter.
Yes, 22.
And then you have a socket properly.
1.2 meter. Yes.
so there
That
may
is
be-
why I'm not getting any issues if it is properly installed on rock. But I don't think it is but the settlements are coming only 50-60 mm. In fact, even after reducing the stiffness of the rock to very low level, I considered poor quality rock also. But still, such settlements are not coming.
So we could actually attribute this entire thing is that it was not properly embedded in the rock. That's the major issues.
Yes.
And
How
that
they
led
ensured it at the site has to be checked, because we don't have proper. Only thing they told is it was based on specific gravity that they distinguish between rock and soil.
that would lead to such a huge settlement and such a huge inclination. 2.7.
Yeah, because the clay layer, if that is still soft at that level, it will be. Because maybe in most cases, it may increase, definitely.
Yeah, some case, I would say. Thank you so much. Very nice information. Thank you. So, our next presentation is effect of footing, soil stiffness ratio with axial dynamics of shallow footing. Mr. Bipin Kumar.
Yeah. So I'm going to talk about this particular paper, effect on footing soil stiffness ratio on axial dynamics of shallow foundations. So there are a couple of authors, me and my student. So you see that there is a figure over here, and you have a footing which is usually shallow, and shallow footings have a slenderness ratio of 0.2522 LP by RP. LP is the length and RP is the radius of the footing. And the footing is embedded in a soil, and the soil is resting on a rigid bedrock or a rigid stratum. So when is this problem necessary? So you see that you have a compressor compressor over here, which is basically a reciprocating machine. You have a rotary machine, which is a rotary compressor, and you have an impact machine, which is a forging hammer. So all these kinds of machine need a footing or a foundation to rest on, and when these machines operate, they generate dynamic loads. Okay, and these dynamic loads have a wide range of frequencies varying from low to high. So this particular problem that we are going to solve or that we are going to develop is basically for these sets of application. So what are the formulations that are still available in the literature? Okay, this is a pretty old problem, but there are quite a lot of formulations already available. So you see that there are simplified analysis, plane strain analysis, which is basically a Winkler type analysis. Then there is this cone-based formulation, which again is based on 1D wave propagation theory. And then there is this lump parameter model where you basically calibrate field data to fit in with some inputs for your theory that you have. So there are quite a few authors that have contributed to these particular kind of analysis. Then there is this rigorous boundary element type formulation, which is also there in the literature, quite old. And finite element analysis is always there, but for this kind of problem, there is only one literature that I could locate. So this is by Kaushal and Usima. So all these formulations that you see, they have certain deficiencies. Some of them are based on simplified theories, not rigorous enough. It does not incorporate three-dimensional effect. And they might be based on complex mathematical schemes. You are pretty much aware of finite element analysis. Boundary element formulations, we end up using a software and all. Otherwise, when we are talking about these foundations for these kinds of problems, there is another issue that people have not really investigated or not talked about. These studies consider the footing to be completely rigid. They do not incorporate the effect of stiffness of the footing. So we have developed an analysis, and through that analysis, we have tried to investigate whether the stiffness of footing is actually necessary or not. So you see that I have the same problem. This is my problem statement. I have a footing which has an input of Young's modulus of the footing. And then because this is a dynamic problem, so I have this density as well. This footing has a radius RP and has a length LP. And the base of the footing to the top of the, or to the base of the soil layer is basically H. The soil is basically homogeneous. This is a soil stratum. If you look into the literature, this is usually defined as a soil stratum when a soil is resting on a rigid bedrock. So there are few properties associated with the soil as well. The first thing that we do is basically we have an applied load, axial load, and we consider a r theta z coordinate system to solve the problem. The first thing that we usually do is consider a displacement field for the soil, which is given by this particular equation. And in this particular equation, you see that uz is the displacement of the soil, which is equal to w multiplied by phi. W is basically the displacement of the pile or of the footing in the vertical direction, and phi is basically the soil displacement function. So we begin with this assumption of the soil displacement field. Next, what we do, we take this entire problem and apply the extended Hamilton's principle, which is basically nothing but a dynamics part of the virtual work principle. Okay, so in this equation, you see that there are parameters k, pi, and WNC. K is basically the kinetic energy of this entire system. Pi is the potential energy of this entire system, and WNC is basically the work done by the external force that you're applying. So these are the equations that you see. So in K, this particular first term is the kinetic energy of the footing itself, and these two terms are the kinetic energy of the soil. In the second equation, the first term is the potential energy of the footing, which is not considered in the previous analysis, and these two equations that you see, the potential energy of the soil. And this is obviously the work done by the applied external force. And all these equations are actually expressed in terms of this particular displacement field. And obviously you're using the theory of elasticity, which is used in any continuum mechanics work, or elasticity theory. So we put all these equations in this particular equation, and then we apply the necessary mathematics, or do the necessary mathematics, variational principle. And we arrive at the differential equation for the soil, and we also arrive at the differential equation for this part of the soil domain, and then we arrive at the differential equation for the footing. Okay? So let's go back to the first differential equation. So this differential equation contains this particular parameter gamma, and gamma is basically describing the rate of decay of the soil displacement with increasing radial displacement, increasing radial distance from the footing interface. Okay? So now there is an analytical solution available, or it can be solved analytically. Otherwise, we have to do numerical solutions, which we usually avoid. Then you have a solution for this differential equation as well, for this part of the soil. And in this equation, you see that there are parameters Ks, Ts, and omega s, which basically are soil parameters. Ks is the compressive resistance, Ts is the shear resistance, and omega s is the inertial resistance of pile, of the soil. Obviously, Ks and Ts, there are two parameters associated, so it is better than plane strain, one cone-based model, and other lump parameter models where parameter fitting is required. Then you have a differential equation for the footing as well, and obviously it is also associated with this Ks, Ts, and omega s, but within its limits. So all these equations that you see, it can be solved analytically, and because you see that this Ks and the solution of this particular footing, which is given by W, they are interdependent. We write a MATLAB code there is an algorithm, an iterative algorithm, and we use it to obtain the solution to the particular problem. So you see that there are two figures over here, and in these two figures, this y-axis is basically the real part of the stiffness versus the dimensionless frequency, and this is the imaginary part of the stiffness, which is the versus the dimensionless frequency. And you can see that these two quantities are given in this particular equation, where these, if someone who is working in dynamics must be pretty familiar with this equation. So this Kv is nothing but the stiffness, which is very similar to the F equal to Kx equation. But this is, because this problem is dynamic, so you have dynamic quantities associated with it, and that's why you have frequency in the x direction. So we have validated our model with this particular finite element framework, and we have got a pretty good match for this particular problem that we have had. The amount of difference that we got for the static stiffness was about 6.5%. Okay, so we have solved quite a few problems, and there are some range of differences which could be somewhere around 15%. But it's not necessary that this particular method is completely perfect. So the thing that we wanted to investigate in this particular paper was basically the effect of footing soil stiffness ratio. And what we have done is we have this LP by RP 0.25, which is basically the footing slenderness ratio of 0.25, and we have EP by ES, which is basically the footing soil stiffness ratio. And we have obtained the results of the real part and the imaginary part of the stiffness and plotted it against the dimensionless frequency. And we have obtained the results for various values of EP by ES, which is basically the footing soil stiffness ratio or footing soil stiffness contrast. So you see that there is not a lot of difference when you keep on changing this EP by ES in the real part. The difference, if you compare with EP by ES 50 and EP by ES 2500, you will get around 7% of difference. Okay, so that is at the static level, but if you keep on increasing the frequency, the difference reduces for the real part. While for the imaginary part, if you look at this imaginary part, I have presented an exaggerated view, but you look at the axis, this is 4.8 and this is somewhere around 4.94. So there is not much of a difference. It is about 7%. So this is for LP by RP 0.25. Again, when I take an LP by RP 2, the footing slenderness ratio is about 2, which is a higher value. You see that again I get a certain amount of difference, and the footing soil stiffness ratio does affect the results. So assuming it to be completely rigid might not be valid. However, depending upon whatever your engineering requirement is, you would want to go for a better accuracy. So then you can incorporate the stiffness of the footing as well. So you have some results over here as well, similar results to the previous slide. And the another one important aspect that gets affected is basically this particular resonant frequency that you come across when you plot it against the frequency. So all these results are available. So the conclusion that we have drawn is basically we have developed an analytical model, which obviously is very accurate. Quite accurate, I should say, when I compare it with other finite element analysis as well, or other boundary element analysis. The method produces accurate response for shallow footings. The thing that we wanted to investigate in this particular paper, the analysis is employed to investigate the effect of footing soil stiffness ratio. It is found the effect of footing soil stiffness contrast, which is basically the footing soil stiffness ratio, can be incorporated in design for EP by ES less than 300. So if the ratio of the foundation footing stiffness, the footings Young's modulus and the soil Young's modulus is less than 300, then you can incorporate, or then you should incorporate the value of the Young's modulus of the footing as well while doing such an analysis. So this is the conclusion we have drawn from this particular study. In the literature, nothing is done for shallow footings with slenderness ratio from 0.25 to 2. So that's why this study was conducted, at least to quantify as to what is the amount of difference that you can have. So this was all from this particular presentation. Thank you. If you have any questions.
Thank you. Any questions? Anyone? Thank you.
Yeah, thanks.
We have a next paper on thermal assessment of geothermal micropiles as a sustainable heating cooling solution for existing buildings by Arvind Kumar.
So hello everyone again. So this I present from my postdoctoral work from NTNU Norway, that where we are doing some field study there, and there we investigated the micropile, because in earlier presentation we saw geothermal pile. So geothermal pile are mostly installed in a new buildings when we are pre-planning and constructing the buildings. But what to the buildings that is already constructed 30, 40, 50 years back, and we forgot, or we did not plan enough, or we did not think for the future, and we did not install the geothermal heat exchangers in those piles. And now, as we see that, if we see the building scenario in Europe, mostly where I work in Norway, we see that more than 40% on average buildings are 60 years or more than 60 years. And then if we consider the whole building, more than 90% buildings are more than 30 years, and then these geothermal heat exchangers are not installed in those buildings. So how to do retrofitting for those buildings, as we say, energy retrofitting. And if we see that, if we want to go into meet the Paris climate target by 2050, over 97% of the European buildings has to be energy retrofit, because in Europe, approximately, if we see 40% of the energy consumptions are in the building, because they require a lot of heating and cooling demand in Europe for the buildings. And if we see that 50% of the gas consumptions in Europe goes to heating of the building, and they are producing a lot of carbon dioxide. That's why in Europe we are trying to energy retrofit our existing buildings, and then that will be the only possible way to cut the CO2 footprint in the buildings. How to do that? If we see here, to meet the Paris target, we have to have at least 60% of the buildings sector to retrofit by 2030. That is, I assume that it's going to cross anyway, that will not be possible. So we have to target by either 35 or 40 to do so. And if we see how it is complicated, that how we cannot install energy piles, because if we see the scenario, this is you can say concrete network of a city. And at the many places we have a historical monument where we cannot change any design or any new construction to the upper structure. So how it is possible to energy retrofit this system? What we can do, that we install micropiles, and it's that micropile is not a new, that it has been used since Second World War, that to underpin the buildings and then provide additional support of the building post-construction period when we see a high deformation. Why we use energy micropile? Because the machine is very small and it can go into the basement and install the pile. It creates very less vibration and then very small diameter pile. For new building, it can go up to 300 mm, but for existing buildings, mostly it's in the range of 100 mm to 150 mm, and it can easily go into the basement and install the micropile. Depending on the design, the length can vary from 5 meter to even some buildings have used 50 meter, but that is very rarely in that case. And we utilize opportunity here that when we are doing the strengthening of this existing building, we can install loop in this energy micropiles itself. So further we can utilize this for the energy or heating and cooling of the building. So if we see the type of micropiles on the base of construction, so these are the older versions where we grout the micropile in a borehole, and then either it can be a gravity grout only, otherwise we can put packers at different spaces and then pressurize these boreholes to have a bigger, you can say, a different bulk in the pile. But recently there is a popular type is coming that we call type E self-drilling, where you have a reinforcement bar, I would say, that is centrally hollow. It has a drill bit, it just rotates, drills the hole and then grouts at the same time. And then we leave this central bar as a reinforcement there. So it's pretty fast process that you can install one micropile in 1 or 2 hours compared to these, they take much more time. So this is gaining more and more popularity in Europe. So this is one of the classical example in a Turku, Finland parking facility where they installed 2,000 micropiles where length were varying from 15 to 55 meter. And they installed U-loop as we discussed earlier in micropiles, and now they use this for de-icing of the surface and then heating and cooling of this adjacent building. And it's been working from last 5 to 7 years. It's installed in 2017 or 18 if I'm not wrong. But only thing to consider that they had to install these pile diameters little bigger because they used U-tube. In most of the buildings we have pile diameter quite small where we cannot install the U-loop. So here we are proposing a solution that generally what is that if pile diameter is big, you have a U-loop that can usually install. But what happens that most of these self-drilling piles are like this, where you have central reinforcement and this reinforcement is hollow from the center. So we come up with a solution that this type of separator's tubes comes in a market for the borehole. Why not we install this separator's tube inside this hollow portion to look it like this, and then we can utilize this pile as well as an energy micropile. Otherwise, there is no way to utilize these piles as energy micropiles. So we did some numerical simulation. I made a numerical idealization of this tube as a single tube where half is bifurcated and then half portion is used as inlet and then other half is used as outlet. So this is inlet of the fluid, this is outlet of the fluid. We wanted to compare that if we're doing thermal performance, then how much are these processes, how much giving more or less energy compared to the traditional U-loop. We did some numerical simulation and we see that indeed the separator's loop is giving around 15 to 20% lesser energy extraction or energy storage compared to the traditional U-loop. But the benefit of this that a lot of the micropiles in upcoming future are not going to be utilized as energy micropile because we cannot insert the U-loop in those piles because of the less diameter. But we install separator's loop, then what will happen that at least we can operate on 80% efficiency, and that will be much more useful because previously we saw that compared to the traditional heating and cooling systems, energy piles, geothermal energy is quite useful. So again, this is the U-loop and this is separators. We see that, and then we see that separators is, in terms of energy storage, it's around 50 watt, where separators is around 40 watt, so approximately 15 to 20% less. Why this is happening? Because if we see to the previous image, because of these arms, so this is known as shank space between inlet and outlet arms. Here it has a wide space, so there is no any thermal interaction between these two arms, at least not as much as in this, because in this thermal interaction is quite close because inlet and outlet loop are very together, stick together here. So that's the reason that in separator's loop we have thermal contours very close to each other and most of the heats are dumping close to the loop. That's the reason that it's giving less energy. So we took this to the field level as well, where we had installed 2 energy piles that we are monitoring that in Norway, and then we installed 6 micropiles in these locations. As we see that during the installation, we see this central reinforcement, a central hollow bar that goes inside, and once we grout that, it's look like that. And we have central space here. Then we insert loop, that we saw that loop, separator's loop inside the micropile, and once it is done, it's look like this. So here we were installing last year November when we saw temperature dipping to -5 and we were all soaked in water installing these piles. As we see, when we installed all 6 piles, it's look like this, where we use 2 type of loop, 4 separators loop and then 2 coaxial loop. In earlier PPT, I discussed that how the coaxials look like, where we have inlet and outlet in the same tube as well. And this is the team when we install, we take help of some consultant companies to install the micropile, and this is how the site is looking now. So right now, before coming to India, I started the operation, so operation is going on, and then very soon we will get some result out of it. As we see that, we concluded that energy micropile can be a very good solution for the energy retrofitting of already existing building if we want to improve the energy rating of the buildings. And then, though the separator's loop is giving 10 to 50% less energy, I would say extraction or consumption, it gives a wide range of opportunity to utilize this technology or this type of loop in buildings where the less diameter of the energy micropile is there. And then I believe that at NTNU, we are doing for the first time in a highly sensitive clay, so we will get some very good data for thermo-hydromechanical characterization as well, because the clay is completely saturated and very sensitive. So I believe, as we discussed earlier, that THM is very important for the energy or for the pile load capacity. So with this, I acknowledge the contribution of Professor Singh, and then Malaysia and Alexandro and our industrial partners, those supported in installation, and then Lake DSC who funded this project. Yes, thank you.
Thank you. Any questions? So you have something?
So you said micropiles are mainly meant for the existing buildings, right?
Yes, sir. Mostly we can use for new buildings as well if we don't want to go for a very big diameter piles. But mostly when it's actually in Europe, they use this extensively for the under supporting of the building. So suppose that after 30-40 years, they have a very chunk of old buildings that starts to settle. So once you see that building is settling, they go to the basement, install the micropiles to support the buildings.
But for new buildings, as you said, separator loop is not energy efficient, right, in storing.
So for the new building, so suppose that if we go here, let me take you here. So this is happening for the new building. So there are many places where you don't need very big piles. So there people go for micro piles as well for the new building as well. Now these piles cannot be utilized for energy piles because these piles diameter are small and then you cannot install a traditional U loop. So you are bound to have separate boreholes. Either you can have separate boreholes to have a shallow geothermal energy that will again consume that you have to have a borehole to dig a borehole, you have to spend the money, and then it will take another space as well for the borehole. But with this we can install loops in this pile itself.
So what is the material, the separator that you are using?
This separator is mostly with either PVB pile or SDP pile. So high density polyethylene.
So here it is, your heat is entering one side of the separator and then
yeah, so here we see that here two bifurcation is there.
Yeah.
So if I see numerical aggregation, so in the center of the pile, two bifurcation are there, and at the end, these are joined here. So if you look at here, this loop is jointed together.
Okay.
So water enters in a one way, and then exists in another way. So we get the proper loop in single pile itself.
Okay, thank you.
Thank you so much, Arvind. Thank you, everyone. We had a very good session, and Arvind has presented two papers and micropile in one was a energy pile and another was an energy micropile. One was for the new building, another one for existing building. So some of the good studies what we have heard from Arvind, and it's a very nice presentation what you are giving it to it. Another presentation which basically have given us some kind of a discrimination between X-ray CT analysis and density log when we are basically arriving the SPT value by bore logs and how the differentiation we can see from X-ray and CT analysis. That was also a very nice presentation. The sinking of large concrete slurry tank, something new what we have seen. It's really amazing study. I want to know the solutions what that's going to happen because it's a huge tank over here. And of course we have found a little bit of about the footing soil stiffness. The equation what sir has presented was something to learn for shallow foundation, and we found that there is one gap where dynamic analysis of shallow footing when the equipments are resting and giving some kind of a vibration, that analysis is not being taken care, and it's a good equation and can be taken it more ahead in terms of studies. Thank you everyone for hearing us. Any questions, anybody?
Yeah, and we thank the organizing committee as well as the coordinators for giving the opportunity to chair the session.
Before we conclude, I request Ravikiran Vaidya sir to please present a memento to our chair, Dr. Hariprasad. And I also request Sujan Kulkarni sir to please come forward to present a memento to our co-chair, Shabna ma'am. I request all the presenters and all the audience to please come forward to have a group photo so we can conclude the session. All of you can join, please.
In person, so you won't be able to join. So our online meeting is only going to last maybe 15-20 minutes, okay, and then we go to our workshop. So before I start, I just want to give you, this is our second meeting of 2025. We had one in April, so this is the follow-up meeting in October 9th today. So let me give you updates on what we are doing. I'm going to give you, this is our agenda. Some of them is just to show you what we are doing with respect to the conferences that are coming up in the next 3 years. And most other things are like, just you probably know, but I think we'd like to get some help from you. So this is our TC307 references. I'm not going to read every one of them, but you can see, as long as you work in these topics here, it is within the auspices of TC307. Tony Smawak from Norwegian Geotechnical Institute, she prepared this slide long time back in Lisbon. So I'm using this so that any new members, they know what we exactly are doing in TC307 scope of our work. So hopefully, if you are working any of these areas, please try to collaborate or work with our committee. Now some updates. So we are now at this conference in Goa. It's a beautiful city here. It's a little hot area, but it's pretty weather, wonderful weather, great actually, hospitality locally. So this is our first Asian international conference. It's called Geotech Asia. It started, on October 7th. We are in the third day right now. We have one more day left. And this is in-person meeting. So the Indian delegation has actually helped us with this event. I had to mention several names, but the first one is obviously the IGC president. He really wanted TC307 presence, so he's been contacting me, so we agreed to do this workshop. So I want to thank Anil. And then I try to do this workshop with the local involvement. So I have a lot of help. I know Akanksha, she's trying to bring some people, because this room is a little bit far away, so people are not able to find where we are, so she's trying to get some help from and she'll be coming anytime. But she took a lot of, lead role in this thing, helped by Ramu Bariga, he also helped, and Shirish is here also. So, and Madhavi Lata, she's going to join us in a few minutes. So these guys are local, so I'm very happy that, I was talking to our president of ISSMG, Mark. Mark actually is going to come and give opening remarks at our workshop later in 20 minutes. Again, I want to thank Akanksha for all the work. So this is the slide she prepared for this workshop. We have roughly 7 talks, so hopefully everything will go smoothly. I really asked her to take the lead of introducing them. I'll do a little bit of introduction of initial, and then I want to give the role to her, and then Ramu also can help her, okay? So we want to see the new guys take over and help us with these kind of activities. And unfortunately, this event is not going to be on Zoom because of some logistical challenges, so it's only going to be for in-person only. So again, we apologize for that. Then I want to give you an update on the Vienna, Austria. Sorry, I should have said Austria. I don't know. I feel bad. Sorry. It's yesterday night I was working, so I apologize. So it was late in the evening. So yeah, this is Austria conference. You already know. I'm pretty positive. Okay, I think it jumped off. Okay. So anytime we change it, it'll go off. Oh, that's something. Okay. So this Austria conference, I'm going to give you an update. Right now, they are reviewing the papers. There are a lot of papers are submitted from each country, member country, so they're reviewing. Once that process is over, we'll know how many papers in sustainability we'll have. Based on that, they will allocate some sessions to us. So that will take few months. So I definitely know we have plenty of papers in our committee, so I will know more in the next few months, and I will let the members know by email. Okay? I think, both Nuno and Evelyn submitted a request for a workshop, and we do know that there's a lot of interest in doing this workshop. I will also see whether we can work on this workshop, and it all depends on whether we should do a workshop or maybe transfer some papers from the submissions into workshop. All these things are up to us, okay? We don't have to do a complete new workshop. We can use the papers, because they have very limited sessions, so some of them we can move into workshop. So they give that flexibility. Again, the workshop participants will have to register for the conference, but no extra cost for workshop is required, which is a good thing. And one thing is, you probably know, so I think, Nuno did work on this TC307 honor lecture with me, and it is all approved by the ISSMG. So we have a Sustainability Geotechnical Engineering honor lecture series is going to start. I see when we request names, some of you are not providing you should be able to send your interest. We really need you. I know this is not for us, this is for you guys to come up. If you are working something interesting, obviously voting is important for the ISSMG, we'll do it, but feel free to put your cap into it, okay? It may take sometimes 3-4 attempts before it gets selected, but in my opinion, this is one way we would like to have you guys in it. So, and we just have our first speaker chosen. It is Professor Abir Altaba from Cambridge. We are very happy that she agreed to be our first speaker for this honor lecture. She'll be giving this talk at the conference in Vienna. Again, this is her title of her topic, Sustainability Innovations in Geotech and Geoenvironmental Engineering. She's going to talk about materials, processes, and applications. Again, I want to say congratulations to Professor Altaba. We do have 2 more honor lectures coming up. So we are very busy, okay? So we just started, and we already have 3 in the next 2 years. So the second one is CREST conference. Nuno started getting some requests from some other members. We need to have 3 members minimum to do the voting. That is required by ISSMG bylaws. So we are in the process of doing it. We'll be doing some, if you are interested, please send us a short CV and send it to Nuno and me. We'll be happy to do this thing. And again, this is one going to be in the CREST conference in Cambridge in 2026. Then the first ICSGE conference in Lisbon, that is going to be our 3rd speaker. So we have 2 more coming up. So I strongly encourage to either nominate yourself or nominate a colleague. Please do that. It doesn't have to be always a member. Anybody can be nominated. Let me give you a little bit of an update on the CREST 2026. So I was talking to Ramu. Ramu said he's very interested in helping a workshop here. We do have a workshop. I did visit Cambridge in July, met with the Stuart and also other folks that are involved with the CREST conference. So they are interested in us having half-day workshop. So we can do a workshop also, just like we did it in, remember Akanksha, we did it in Kyushu in Japan. So we can do this next one in next CREST on the first day of the conference. So if you didn't have a paper submitted, we can still do a workshop presentation, if that will allow you to come and visit Cambridge. They're trying to make it very affordable. I mean, that is really, I appreciate them. Gopal Madhabush he mentioned that is one of the things. And I just had my first visit Cambridge. I never visited there before. I had a fantastic time. So I hope you can come there. Both Hemanta and Evelyn E are going to be my point of contacts for that conference. Evelyn did his postdoc there. Evelyn, I hope you will take a lead on this one, on the workshop also, along with Ramu, who said he's very interested in collaborating. So I'm going to engage you guys, okay? So to do that. And this is the latest one. Can anybody check and see if we have more? Anybody from Antonio joined us on this? Or we have, let me see if, okay, we have Catherine here. I'm just checking and see if any of the speakers from, no, they did not. Okay. So I know it's an odd timing, and I know they're all probably have, I think, Ramu, I may need your help again. So, yes, showing up. It's good. It's working now. So let me give an update on this one. If you recall, 2019, we were supposed to have this conference, but due to COVID, it got canceled. This is the first Portuguese society wants to do it. Now they came back, they want to do this in first international conference on sustainability, and they're very passionate about it. I'm very, very thankful to them. Castellina, I need your help, okay? Just like other people, we're going to need your help. And I think all the Portuguese, my committee members, everybody going to help, Nuno and Sarah, everyone, I'm looking forward to getting your help. So this is going to be in June 28th to July 1st, 2027. If you've not been to Portugal before, please try to go there. It's a fantastic place to visit. I have 4 times already to Portugal. I'm going again next year. I'm going again 2027. So you can imagine, it's a wonderful country to visit. Great folks, so I really think, we do. The organizers are Antonio Roque and also Joanna Carrito, I met her, and Luis Miranda, and then Nuno Cristilla, I mentioned him to be the point of contact from us, so he's going to work with us. I did meet with the president of Portuguese Geotechnical Society, Castrina, and Professor Paula Oliveira, he's here, so I did meet with him. He is very interested in, helping us with this conference. One thing is, I was told by Antonio, he sent an emails to every one of you to be a part of the technical committee. If you are wondering who is it, what is this is, now I think if you now know, if you can look at that email and say yes or no, if you don't want to do it, that's totally understandable, but please send them. All it is going to be a technical committee member, and they're very much interested in you to help with this conference. This is truly TC307 conference. Just like CREST is a co-sponsoring, whereas this is our own conference. So a lot of sustainability stuff, guys. I can't even put my head into, there's so much work. I really need everyone to help me, and I think, again, Akansha, you did a fantastic job here. I just want to say, this is something we definitely need to do that. So I think that's the last slide I have. I don't have anything major because I know we're going to have a workshop starting in a few minutes. But I'm happy to see if any of the members on online, we have like 6 or 7 members. I see Catherine, you joined. Thank you. If you guys have any questions, unmute yourself and ask me about this presentation, short presentation I did. But basically, I can see we have 3 events coming up in the next 2 years, starting with Austria, followed by CREST, and then 2027 we have this first international conference on sustainability in geotechnical engineering. So these are the 3 events. I don't want to commit. There are a lot of people are asking, but I don't want to overcommit myself because I'm going to be in trouble. So I think these 3 is enough for us in the next 2 years to keep us engaged. So I'm happy to answer if you have any questions. Evelyn, you are unmuted, so you have a question for me?
No.
Oh, you just accidentally unmuted yourself. Okay. Yeah, I'm glad you joined. So thank you.
No problem.
What is time in Singapore?
It's not good time. It's just 6 p.m. So actually, I'm just using my cell phone because I'm, on a bus.
Oh, I see. Got it. Okay, Sarah, you have a question for me?
Just, I would like to appreciate this meeting and the effort to tell the members to reply to our emails on the conference, because we are doing a great effort to put this conference together. What I realize is that it is difficult to do these meetings because probably of the time zones, and so each time we do such a meeting, we just have like 6 or 7 people or 10 people at most. So it's always difficult to gather people together and do an event all together. I don't know how many members the TC307 has, but it's never possible to have everyone together. And probably that's the reason also, because we are not receiving the replies to those emails. Not sure how we can do that eventually. I don't know I think you are doing a great effort to do these meetings several times in different time zones. I don't know any other option. Not sure how the other TCs do.
I mean, that's a great comment. I actually agree with you. It's very challenging compared to east to all the way to the west coast. I mean, if I do something, the Australian folks have a difficulty. If I do something in, the best place to be is Europe, okay? You guys don't have any big major issue. But either America or Australasia are always in tough zone. That's why I try to change it, but you're right. What I think I could do is we could create an email like a listserv. So, I mean, I can go by role, but I don't think we need we have 50 members. We don't have to have all 50 members to be part of the committee. Even if we get to 15, 20, that's plenty, is my opinion. So I think I now know, like we have enough folks here that we have almost like 9, 10 people, which is typical, But again, we also announced it only 2 days back. Thanks, Akansha, for taking last minute help on this one. I just, as I said, I just thought it's a good time to do the meeting. I've been thinking about this meeting, but trust me, if these conferences are taking a lot of time of yours, right? So, but again, we will try to do an email and then check with few people who are interested, and they can be yes or no. Either way, if I don't hear from them, we'll say you are no, or I can scare them, say we'll put you as a yes, and then we are going to be reviewing 10 papers, something, we'll scare them. Yeah, go ahead.
Okay, thank you.
We'll do that. Hey, Catherine, you have anything you want to comment?
No, not really. I just happen to be in Japan time, so it's
yeah,
not too bad. If I was in Canada, this time would not be so great, but I am in Japan right now, so it's it's actually it's not bad. It's like 7 o'clock now in the evening, so it's not so bad.
I was about to give you a best remark, saying that if coming from Canada early morning, you were able to join.
No, not so good.
So you were in Japan. Okay, good, very good. But I still, I think, appreciate you joining and thank you. But I think, as I said, if you guys want to join on the Portuguese conference, please try to join us. That's going to be an interesting event. And I think ICSMG is interested, and then the Portuguese Society is taking lead. So I think, we are in good shape with that. So, yeah, I think, Maria, I don't know if we met before. If you don't mind, could you introduce yourself, Maria Santana?
Hello, morning from Spain. I have been in another meeting before with you, the previous to this. Yes, I'm working in CEDEX. It's a government institution.
Okay.
So, and no more comments from my side. Thanks.
Thank you, Maria, for coming. Did you get the email from the ICSGE conference folks on joining their committee? Because some of the members may not have received. I want to make sure that everybody got it. Did you get the email to join the technical committee?
I'm going to check because I think I didn't get it.
If you didn't get it, could you please email me and Nuno, so that way sure that you will send the email. So that is one thing, because we send them the Excel file, they're sending directly the conference organizers. I think that is one thing probably causing some, because it'll be better if it comes from one of us. So either way,
okay,
so we'll
I will check.
Help.
Thanks.
Yeah, thank you. So I don't think I have anything, guys. So we have a workshop starting in 4 minutes or something. So I will close our meeting, but if you have any questions, don't hesitate to email us. Evelyn, myself, or Nuno, one of us can answer it. So include all of them. Mizanur also. So he didn't join us, but I think we'll be happy to answer it by email. So thank you for it, for the thing. And then again, one thing I really wanted to remember, all of you, is try to nominate yourself or someone for honor lectures. We really need your help with that. Okay?
Can you send the slides to us?
I will email the slides. Yeah. Akanksha has already all the slides. So Akanksha, if you don't mind, please share the slides to all the members later, not now. Okay, whenever you have some time, post-conference. We will do that, Catherine. Thank you,
Perfect.
guys.
Thank you.
Thank you, everyone.
Thanks.
Bye-bye.
All right, thanks.
Take
Thanks
care.
Thank you. Have a good time.
Bye.
Bye.
All right. So what is the next one? Is we going to change the computer or? What is that? You guys signed up? Yeah, if you signed up.
Check.
This is our focus in our company, Keller Foundations. Thank you.
You're from which place?
Keller Foundations. Keller Foundation.
Which country?
My office in Singapore, but we are belonging to Keller Asia.
So I just want, the reason I was asking is, one of the things we are academics, we like to have more industry work. You can ask Singapore Society for they can nominate you as a member of ISSME or this company, that would be great. One of the things I'm trying to do is have more industry members. Since you have such strategy interest in ground improvement, I'll work. But I can help you. I know it's a Singapore Association. Okay?
Some engineers to take care of the sustainability. We are doing the carbon emission calculations every project. That's important.
You're saying you're not interested.
I'm part of it.
You're part of it.
Myself, Mohammad Mansoor. I'm a research scholar at IIT Jammu. I'm also working on geosynthetic technology. Hello everyone, my name is Sushant Rao and I'm a research scholar at IIT Roorkee. My research area revolves around rainfall due to landslides and the probabilistic bank analysis and using the coupled flow deformation analysis. Thank you.
Hello everyone, I am Kirtika Samanta and I am a marine geotechnical engineer from ITT Cementation India Limited. I also did my PhD from IIT Roorkee. Thank you.
Hi everyone, my name is Sonam. I am currently doing PhD at IIT Roorkee and I am working on artificial intelligence based landslide susceptibility assessment. Thank you.
Hello everyone, myself Shweta Singh. I am research scholar at IIT Roorkee and I am working on granular anchor pile foundation system. Thank you.
Hello, myself Dr. Syed KK Hussaini. I am an assistant professor at IIT Patna and I am working on railway track geotechnology.
Hello everyone. So this is Krish Salve. I'm a final year master student from ISC Bangalore, and I am under Professor Madhvi Lata ma'am, and my main research work is something regarding 3D printing, geosynthetic, and all computation work and all. Thank you.
So good afternoon all. This is Prasad Nayak. I am a research scholar from IIT Patna and working under the supervision of Ramakrishna Bha. And my topic is on thermohydromechanical behavior of buffer materials. So an application to isolate hazardous waste. Thank you.
Hello all, good afternoon. This is Abhishek. I'm working at IIT Hyderabad as a PhD scholar under Professor Sirish. So we are focusing mainly into drainage geocomposites.
Hi, good afternoon everyone. My name is Pratik Chaudhary. I'm a research scholar at IIT Hyderabad. I am working with Professor Sirish and my research area is on autonomous vehicle and its payment responses.
Hello everyone, myself Vaishnavi. I am a research scholar at IIT Hyderabad and I am working on application of UAV techniques for seepage detection in earthen dams. Thank you. Bye.
Hello everyone, Suman Jain. I am from Pune, IGS Pune chapter, chairperson, and also I am working in the design department of Garhwale Technical Fibers Limited.
Good afternoon to everybody. I am Ramesh Kulkarni. I am with Soil Tech India Private Limited. We are in ground engineering. I am working in this field for last 57 years. Thank you.
Whoever is in charge, Mark comes, maybe after that talk, Oh yeah, sorry.
I think it's Dr. Ramu here from IIT Indore. I'm working in as assistant professor in geotechnical division. So majorly I work on geosynthetics and sustainable materials performance. So nice seeing you all here.
So Ramu and Dr.
Hi, this is Guna. Look forward to this interaction. Right from
So, a very good afternoon to all of you, and thank you for coming here. I know finding this room was difficult for all of you, and I'm expecting more people, especially from Women in Geotechnical Engineering group. And so this is sustainability practices for smart geotechnics. And thank you, Prof. Propala, for giving me this opportunity to arrange for this workshop. Although I didn't do anything, I'm really thankful to our speakers who actually gave their consent to be part of this mini workshop. So these are the speakers lineup is which is shown over here. And first, I would like to welcome you all. And I would like to invite Professor Anand J. Pupala, who is also the chairman of TC 307, Sustainability in Geotechnical Engineering, to give the welcome address.
I actually thought I already did that, so I didn't want to do it. But one thing I want to give you opening remark. How many of you know the geoengineering website, ISSMGE? Okay, this is good. I would like every one of you, please sign up for TC 307 newsletter, so we can send you the updated information. We have already 1,000 people, around 1,000 people already signed up with the TC 307. Also, everyone can bring 4 people that you know, in your classmates or somebody, ask them to sign up. That'll be great boost for us, because we are one of the top 4 most interested, because a lot of young people are interested in sustainability topic, okay? So please tell them, a lot of them do not know. So all you have to do is look for geoengineering website and then go and sign up and then tell them that you are interested in receiving. You can, not only our company, you can look at other companies that you are interested, and you can say that, hey, I'm interested. If there's any news item coming from them, I would like to receive them. So automatically they receive it. So I think, here is our big boss here, Mark. I really appreciate you coming. So I'm really honored, Mark is a good friend of mine. So Mark, I requested him to give opening. Mark, you look at the young people that we have there. And then we
very young.
Exactly. And he has 57 years of experience. So he's going to give every bit of it to us today.
Yes.
So one thing, Mark, I would like to give it to you for opening remarks. So, you also did our talk, the important talk with each companies that you have the talk series. We are number 3 in that list. Third one.
You already did it.
Yeah.
IITT. Did you see that episode? It's very nice. So we're bringing together young and renowned from all over the world to talk about one subject, and sustainability to me is the most important one. I want to thank you for being active, because there are many TCs and many are dormant. So you are one of the most active. So I really appreciate your efforts. And actually, in a few years, it should be the only geoengineering subject, sustainability. The way the world is going is not in the right direction. So you are reversing the process. So I want to thank you, and thank you all for being active and understanding the problem and helping the society. And I'm here to listen and see how we can help even more. Thank you, Anand.
So Mark, one thing, if you don't mind, we'll take a quick picture that really the people who put all the effort are local folks. These are our members, Akanksha and Ramu. One picture with all of you is very good. If you guys don't mind, can you come with our president for a picture? We have the photographer here, right? Yeah.
You want to put the logo on the screen?
The geotech. Somebody take a quick picture, guys, for our website, for TCC US. No, it's okay. I'll take it from them. It's okay.
The presentation first.
Only one. Just leave. That's it. I'll just leave. Good afternoon. Thank you so much for inviting me to present something on sustainability. Myself, Sirish, I'm a professor at IIT Hyderabad and also chairman for recently funded School of Sustainability at IIT Hyderabad. It's called Greenco School of Sustainability. Greenco is actually a leading renewable energy company in India who's almost sponsoring like 150 crores endowment. Okay, so I hope are you able to hear? Okay, so outline is very simple, and we have been talking about sustainability in various aspects. So in this particular presentation, let me also acknowledge my co-author, who is not, name is not presented, who is Anni Srinivasa Rao. He's a mathematician and professor from Medical School of Georgia. And we developed a small global sustainability model, and I'm trying to show you some results from the theme. And looking at the outline, I have some introduction necessity of the study. Then we have some theoretical approach. Then I'll show some results and summary. So Indian road network, as I mentioned earlier in previous presentation, I think we stand next to the United States, largest road network in the world, second largest, I would say, with 6.4 million kilometers. And looking at the sustainability aspect, even to build a small road, like a 1 kilometer, 1 lane, we need about 15,000 tons of aggregate. So, and India is progressing like in the year, 2014, we were looking at something like 12 kilometers per day. And now today, 2024 data shows that we are at 34 kilometers per day. That's the rate of construction of highways in India. And if you count all the next 5-year plan, we have more than 1 lakh kilometers of national highways projects, so which will need billions of tons of natural aggregates to be used. So the idea is to how to reduce this natural aggregates and also make the payments more sustainable. So the idea is not just cradle to grave, but how do you repurpose it? But for example, if I'm using RAP or any recycled material, after the end of life, can I make use of the recycled material as, again, what Mark was mentioning, don't expand but use the material as it is. So can we do that, something to it? And the other challenge that I have right now is, how are we quantifying? So is there any specific number that I can give to sustainability? So for example, if sustainability index is something like every faculty here knows about H index, right? H index 1 to 100 and so on and so forth. So can we talk about a number so that the system can be identified whether the system is sustainable or not, whether we use recycled materials or any energy source materials, is the system more sustainable? And if it is sustainable, if I'm climbing only based on LCCA or only based on the carbon credits, is it sufficient or something more to it? So that's a challenge, and we wanted to see where we stand at this stage. So I'm just skipping, and these are all like payment failures and how we design a payment system. So basically, first two parameters are very important. Any payment is designed for two cases, rutting and fatigue, and that's what I'm trying to show. And all the alternate materials that at least I should thank Professor Puppala here. I was only working on geosynthetics, but I was exposed to various recycled materials when I was doing postdoc with him. With TextDot and so on. So we have very facet of materials available, like right from the beginning, like demolition waste to wrap, that reclaimed materials, even rubber. But of course, some of them are not very relevant for Indian context, like shingles. But otherwise, we have glass and rubber tires and crushed bricks and so on and so forth. So. And all these materials cannot be directly used, and we need definitely some stabilization techniques. So cement is again another non-green material, as everybody know. And when we talk about sustainability, in the School of Sustainability, we are talking about, think about a civil engineer who doesn't use cement and steel for construction. So can we think about a system like that? So a step towards is using alternate stabilizers like fly ash and geopolymers and so on and so forth. So what is RAP? RAP is actually a reclaimed material from asphalt pavement system. The picture shows the freshly milled material, but if you take out the asphalt content out of it, which is like 4 to 5% asphalt that generally we use, this is a very beautiful virgin aggregate which is buried under, right? If you don't use them, what happens is all these material will go into landfills, and we are not talking about any sustainability. So this is the production of RAP across the world, and this is something like 3 years old data. Right now, India stands almost more than Germany. I would say 10, but sorry for the slide, because we have been, last 10 years, I would say that, including Professor Veera Raghavan from IIT Madras and so on and so forth, even Professor Babu, we have been actually advocating for recycling all the materials in India. And then I would say that every single highway expansion project, now we are using this recycling process. So I think we need a strong voice over to accommodate more such projects in India. And on the other side, as I mentioned, fly ash as a waste material, the production is also increasing in India. At some point, we have to cap it with the Paris Agreement of 1.5 degree. But however, even up to 2030, even if you look at, the utilization is also increasing along with the production. So some 30-40% of the fly ash is going waste. So how to capture them and then reuse them in the industry. So with these two objectives, we have looked at various current models, existing models, to estimate the sustainability. Now, if you look at, they are very broad in space. So what we do is, like, for sustainability, we generally consider ESG, socio-economical and environment. But there are other factors like natural calamities and so on and so forth. So LCCA is only one aspect of it. And cradle, as I mentioned earlier, cradle to grave is one aspect of the aspect of estimating sustainability. But there are multiple scenarios. For example, if you look at, so this is a model that we were working on. So if you look at on the right side, there is a table which shows the variability or variables, multiple variables that can go into sustainability aspect. So they may not be very relevant. For example, political situation may not be very relevant, but the value for that or weightage for political stability will be very minor, right? So we have to consider environment and climate change, food and agriculture. For example, if I take RAP, what is the influence of RAP, using RAP in payment on food, is also a factor that we need to consider, because this is, as I said earlier, we wanted to develop a model which can be used for various applications, not just only geotechnical or transportation engineering, but we can use this model, global model, for any kind of problem. So that's the key. We also have included energy, medical technologies, and also science and technology that goes into every aspect. So we have derived the expression with Xi1 to Xi7. There are 7 variables, and it could be extended further. But what we have done is, for the first time in the mathematical modeling, we have developed a system, we have developed an equation that can actually solve sustainability, and then we can give some number to it. Okay, number maybe 1 to 10, scale of 1 to 10. If it is 10, it is highly sustainable. If it is 0, no sustainability. So, I mean, I'm not going into design and derivation part of it, but these are like, there are 3 cases we have derived, and with weightages, without weightages. And yeah, at the end of the day, this is a partial differential equation, PDEs. Once we solve it, we can actually, we can actually solve the equation to get a sustainability index, which can be quantified and can be seen the entire system. Payment system, it could be payment system, it could be a building, or it could be a dam, it could be a new product like iPhone, right? So which can consider the repurposing and entire chain, chain of supply to industry. So in this case, what we have done is we have taken one example, which is again going back to the recycling of payment systems. We have validated the model with the case study that we have done for almost monitored for 5 years. And in this particular design, what we have done is we have laid a half a kilometer road as a state highway, where we have used fly ash geopolymer as a stabilizer, and wrap material as a base course material, and 50% of virgin aggregates. Yes, sure. And these are like construction pictures, and monitor for 5 years, and all the data is presented here. We are not interested in that particular data, but how this can be taken up as a sustainability model index calculation. So these are the values we have considered for range of values for RAP, VA, fly ash, and resilient modulus, and we have designed using these data almost like 250 cases, and then we have conducted the design and then obtained the thicknesses. We have incorporated all these factors and coming from various source of data from Australia to US, and incorporated into the sustainability index. Now, I'm just showing a very typical data here. The y-axis is actually, it's missing. So y-axis is VA content, virgin aggregate content, and x-axis is a RAP content. So for example, if I'm using 50-50 a portion of virgin aggregate and RAP content, you can see that the skewness is reduced, and you can see that balanced sustainability number. Okay. So what is the sustainability number here is not very clearly seen here. It's only a pictorial representation of the movement or balancing of the sustainability number. So this is again 40-60 if I use, but most of the cases if the VA content is increasing and RAP is reducing, obviously the sustainability is lower side because we are using reduced recycled materials. So, and that's why you see a lot of scatter and skewness towards the right side. So then we have quantified in terms of numbers. So if you see that here, the problem is we have only considered just to demonstrate Xi1 and Xi2. That means only 2 variables. One is RAP material, the other one is virgin aggregate. So sustainability index is varying anywhere between 2 to 2.5. Around 2.5 is the variation, even though if I change 10 to 100% variation in the material. But if I consider 3 parameter, as I said, the sustainability model was developed from anywhere between 7 and above variables. So you can see that 3 parameter models, the sustainability index is increasing. So that means if I consider all 7 are very relevant parameters, the sustainability index can be estimated, and we can say at the scale of 1 to 10, I can tell, or at least using this model, we can tell that the product or the system is whether sustainable or not. So with that, I just conclude, and I don't want to read the conclusions, but that's what I wanted to present before you. Thank you very much. Yeah.
Sirish, so since we are having open house interaction session at the end, so we can ask questions at the end of the session. So now I would like to invite. Yes. So I would like to invite Dr. Anil Joseph, who joined us in this TC307 workshop for a address.
Good afternoon all. So respected President Mark, Chair of TC307, Anand Pupula, and other members of TC307. It's a pleasure that we are able to have this as part of this Geotech Asia conference, and I thank Anand and team for doing this session here so that people will be able to understand where sustainability is going about and what we have to look into. And I always think in different forums when we talk about sustainability, and we talk a lot about green buildings, and we are the one who creates the maximum environmental impact. To produce 1 ton of cement, we emit 1 ton of carbon dioxide. To produce 1 ton of steel, we releases 2 ton of carbon dioxide. And we want green cement, green concrete, and we come up. So we have to think what exactly is the replacement. And I think that we have to look at our traditional structures, which are 6,000 years, 7,000 years. They don't have that. Now people are coming to us to design how buildings which will last for 1,000 years. The lifespan of this building using steel and concrete is 100 years, 75 years. So something is wrong in our system which has to be corrected. Look at the old temples, look at the pyramids. For 4,000 years there is no problem. So somewhere we missed the sustainability concept, and now there are few clients whom we are working with who wants to have 1,000 years lifespan, and the first condition is that no cement, no steel in our building. So it's time for thinking that what is the process of sustainability, what has to come in, like geosynthetics. It's a big thing which is happening. So this we are producing that, and how much of saving is happening. Look at the huge massive walls we have before using conventional material. So including transportation effect and the total overall impact has to be looked into. I congratulate the entire team for bringing it, have discussion, think differently, come up with ideas so that what we think as conservative or sustainability now, I strongly feel that we have to go back to the ancient civilization to understand, look at our old temples, how beautifully they have done, and there is no problem, and they were using the material. Take the Ajanta and Ellora caves. So magnificent we have come out with where the sustainability aspect has come into. So let us reinvent ourselves, share our knowledge, come up with concepts which can change, and all the very best for the entire team for bringing it, and thank you Akansha for coordinating this event here. Wish all the very best for this session. Unfortunately we have to run for some of the other programs, but whoever is registered for gala dinner, don't forget to join us. 6:45 assemble in the lobby, the buses will start. Let's have a good time and let us have a memorable conference which we will take it for, and we should think of sustainability also in the process. Thank you very much.
Thank you so much.
Madam, I can continue. I will help.
So next I would like to invite Professor Madhvi Lata for her talk.
Good afternoon, everyone. Thanks to Anand Akanksha for organizing this here. I am going to put forth some ideas related to sustainability because currently I am the chair of sustainable technologies at IISc, where I am involved personally and also at the administrative level on some of the initiatives that we are doing in this domain. So if I look at the way the 3D printing, my topic is related to 3D printing and sustainability. The history by which the 3D printing is evolved from the very beginning, where they were able to just make a metal plate from a liquid metal to using a photopolymerization to the current day where we are standing in this domain of 3D printing. Particularly in the domain of medical technology, if you understand, I am amazed to see that recently they were able to create a ear for an young girl using her own regenerative cells, which is a kind of breakthrough in this medical field, that you are using your own cells and 3D printing other organ and implanted into your system, which will survive, heal on its own. And what particularly interests me in the civil engineering domain is the way the 3D printing is progressing in every material and every functional aspect of our engineering services. For example, in 2012 Olympics in London, I still remember people used vibro-concrete columns to stabilize the field to make athletic ground. But if you look at 2024 Olympics, Saint-Gobain has made a skating park just by 3D printing. So we have come a long way in this direction, and I would think this is one of the exciting fields for the young engineers to, adopt and research and innovate. And coming to geosynthetics, I've been using geosynthetics for past 30 years. My research is mainly in this domain. Some of the important limitations of the conventional way of making geosynthetics through extrusion is they are energy intensive processes. If you have seen these units which produce geosynthetics, they are having heavy machinery, very huge transportation of material from one place to other place, and they also have very less scope for customization. They use high density polyethylene, polypropylene, PET. But if you have to have some interstitial layers of materials or customize some shape, geometry, and some surface texture, it's impossible to do in the conventional way. So why 3D printing is very helpful in this direction is 3D printing can give us eco-friendly options. We have the liberty to choose different materials and we reduce waste. The conventional 3D, the geosynthetic making has a lot of material wastage, which can be completely made zero, net zero when you adopt 3D printing. And we also have, we can save a lot of natural materials, and we use automated processes which are very less, they consume very less energy. You have very small units, robotic arms which can print geosynthetics, and transportation is not a problem because you can set up these units everywhere and anywhere. We started with a very small laboratory scale printing of geosynthetics. I have two 3D printers. One is fusion deposition modeling, which does layer by layer printing. The other one is polyjet printing, where we can mix different materials and make customized 3D printed materials, multi-material printer. So we started printing geosynthetics. Probably we were one of the very few who started 3D printing of geosynthetics in the world. And initially we used polypropylene. People were using only PLA. So we were very, in the beginning we used polypropylene, and we made these geomembranes, and we were able to optimize the surface features of these geomembranes. So you get with the same amount of material maximum interfacial strength and tensile strength. So going forward, we innovated textured geogrids. This is a patented technology from a research group where we were able to create surface texture and geogrids. We have been using plain materials as geogrids forever. Now we are able to induce this surface texture and also optimize this surface texture, and we could create different shapes, hexagonal, square, and triangular. Very easily we could 3D print in our lab. And what is more interesting in here is when we did the load test, with the textured geogrids, with the same amount of material, we are able to get so much of increase in the load carrying capacity with the same amount of tensile strength. So that's the kind of, you are saving a lot of material when you look at stabilizing a road or a foundation. And what makes it interesting is these textured geogrids help in two ways. One is because they have a protruded texture, they increase the passive resistance. The material cannot move as easily as it does on the planar geogrids. The second thing is, since there is a texture, the sand particles sit inside, they get interlocked inside the texture, which will increase the sand to sand friction, which is much more higher than sand to polymer friction. So because of these two simple reasons, these perform very, very efficiently. And next, we also produced geocells using polypropylene. So initially, we were not sure how to 3D print these geocells because these are three-dimensional materials. We printed polymers, the polypropylene sheets. Then I bought an ultrasonic welding system. So like in conventional way, we were ultrasonically welding to make geocells. Now, we wanted to ambitiously do the real geocells, the complete geocells by 3D printing. So far in the world, the red box, what you are seeing is the closest that people could print 3D geocells. My student is sitting there, Krish and Rishabh. These two MTech students are extremely ambitious kids, and they were able to 3D print these geocells completely using the fusion deposition modeling. And we are now testing how these 3D printed geocells will help in increasing the load carrying capacity. Another innovation from my lab is 3D printed geocell anchor cages. These are simple PLA materials which are made into a grid where you have connected anchor pins. When you have a geocell layer, because geocell is very close to my heart, that's my PhD topic way back in 2000. So far, geocells are evolved into different materials, porous, texture and all that. But no one has thought about the structural add-on to this geocell where you put a bezel grid with anchor pin. The anchor pin will just go sit at the center of the geocell, which will redistribute the stresses uniformly and increase the bearing capacity enormously. So this is this is also another patented technology, and and we are able to make foundations, retaining walls using geocell anchor cages. We proved that we save a lot of material when we put this simple PLA material as a base for the geocell. So there's a lot of research done and papers are published in top journals, so these are available for you to go through. Another interesting project in which I am involved very recently is there's a call from the Textile Ministry of India asking me whether will be able to utilize the fabric waste, textile waste which is lying everywhere, anywhere which is being landfilled. So I collaborated with the materials group of our Indian Institute of Science, Professor Surya Sarathi Bose. So we were discussing what to do and how to make use of this textile waste. The problem with the textile waste is it has so much of PET in it, but that's not it. There is so much of other materials like PP, PE, all kinds of polymers are mixed. How to separate this? Generally, when we have this kind of waste, people, what they do is they burn it. They just make a polymer out of it, which is a residue, and then try to make use of it. But instead, to make virgin products, which are value-added products, geomaterials in this domain, we thought of making geosynthetics from this textile waste. So we have the materials group of IISc has a patented technology called SALSO. What they do is they use chemical construction of this entire waste, from which the PET will be stripped off chemically. And then that PET is very strong, and you use that for making high performance polymers, furniture, geosynthetics, or whatever material you can make with PET can be made. But that's not it. The next part is I want to make geosynthetics, geocells, geogrids, textiles. So the residue, after peeling of PET, you have PP and PE material, which is usually wasted, which is just a residue which is wasted. Instead of wasting it, we are able to create geosynthetics using that material, that too with a very high mechanical strength. How we are doing it is we are using a chemical additive. It is called Vitrimer, and we are able to get back the mechanical strength which is lost during the processing and usage of the previous cycle of your polymer usage. So by doing that, you are creating a fresh material, and we are able to have the material with very low molecular density. And it also has the capacity to dynamically interact with other ionomers in the system. So you are able to get very high quality polymers. We are able to print geogrids, geotextiles, and geocells using this process of the textile waste which is coming in. Going forward, there is a robotic arm. You can see this is a kind of, it can print huge slab of geotextile grid or geocell, and this uses photojetting technique. So a wonderful process. I would think this is going to be the future in the industry of polymers and geosynthetics. I would also want to share ambitiously one of the projects of our department, Center for Sustainable Technologies. We have 4 groups: sustainable water, sustainable energy, sustainable buildings, sustainable environment. The buildings group is very actively creating building elements, complete 3D printed building elements using just mud. Earth-based material using geopolymers. You can make these elements. They are very strong as any cement concrete. That is not it. The current project, what is going on is making sand particles using fly ash through 3D printing. So I'm not going into the details. If someone of you is interested, we can connect and discuss that. But just this month, we transported coral reefs to Rameshwaram coast, where there is serious problem of biodiversity. All coral reefs are getting damaged. There is an ecosystem which is getting disturbed. So in our lab, we have printed 1 truckload of coral reefs and transported and installed in the Rameshwaram coastal waters. And we are going to monitor them. We are going to put all sensors to see how it is increasing the ecosystem, the marine species and biodiversity. This is one ongoing project. And some ideas, 2 ideas I want to also put forth. The construction demolition waste. I am involved as one of the supervisory committee member of Andhra Pradesh Capital Development Region. So much of construction demolition waste is generated, and this is being just indiscriminately dumped. So what we can definitely do is use 3D printing technique to convert this construction demolition waste in making building elements and most importantly sand, which is very, very scarce now. And another area in which we can work on is we are also trying to use this glass to create sand, the waste glass, which can be done through 3D printing. This is going to be the future for the next 5-6 years. I would see such technologies emerge and they will be available to all of us. Right now we are also using PET bottles which are thrown. There are like millions of PET bottles which are thrown, which are easily recycled, and we make filaments out of it and use the FDM technique to create geosynthetics and any other polymeric virgin materials. Thank you so much.
So thank you, madam, for such an eye-opening lecture, and it was so interesting. I also lose track of time actually.
I hope I didn't take too much.
Yes, it was well timed. So thank you very much. Now I would like to invite Ms. Dola Roy Chaudhary for her presentation. Thank you.
Thank you, Dr. Anand. Thank you, Akanksha, for having me here. After 2 major serious lectures, it would be a hard task to talk about...
This is the date?
Today's date would be there? No.
PPT?
Come down. Sustainability and today's date.
Sustainability, is it folder?
No, not a folder. Directly.
Sustainability indicators. Okay, I was not focusing on this, I think.
So it would be, after 2 very good lectures, it would be probably a good thing to stir the pot a little. So while we are talking about sustainability, and we have been talking about sustainable solutions with geosynthetics for the last couple of days, it is already well known that geosynthetics are highly well known. No, I'm good. are extremely, they are already very well known for their geo-environmental problems, and these benefits get multiplied hugely when geosynthetic materials are used along with alternate or material like locally available soils, recycled content. You invariably get a much better product value out of it. And a lot of research has already been undertaken in these potential applications, and both those applications were already highlighted in the previous two presentations, especially in terms of recycling, in terms of usage of mining waste, and right now, what looks like emerging technology, probably in a couple of years, we will be seriously talking about getting them scaled for mainstream usage. So while we are talking about 3D printing, yes, we have extremely in all these areas, we have extremely good results. So probably we are reaching that stage where we sincerely need to look into scaling these, and then obviously the next step is going to be regulation, because unless there is a policy backup, the push is not going to be there, because most of our specification still talks about natural sand. So unless and until M sand comes into specifications, is allowed for mainstream applications, the thrust will not be coming in. So with this as the base, these are the applications which geosynthetics is extremely well known, that geosynthetics as well as the natural fiber material, or where India has a major edge because we have the potential and the complete environment for producing a lot of geotextiles which are natural material based instead of only polymer based. The applications are manifold. We have multiple case histories across the country. We have been totally aligned with the SDGs. So with all that as the backup, 2 days back we talked about natural disasters, and India has a legacy of geosynthetic applications, especially for the last 30-35 years. The kind of structures we have built in, a lot of pioneering structures. Currently we hold the record for the tallest RS wall structure in the world. Even a few years back, whatever was the tallest at that point happened to be in India. Similarly, a range of other applications and alternate usage found their first base in India. So yes, we do have that kind of backup already available in the country. That kind of experience and manpower as well as technology is available. At the same time, there is a negative connotation when it comes down to geosynthetics and plastics. So the mass comments about it could not be ignored, because the kind of images we are talking about here, they are very, very sensitive. They are sad. But unfortunately, what happens in a lot of things when it is involved with plastic, everything gets clubbed together. So while when we are talking about geotextiles, obviously geosynthetics, we are talking about a particular grade of polymer. We are talking about CE marking. We are talking about carboxyl end numbers, so which are highly sustainable material, and they really do not, cannot be compared to what we talk about single-use plastics. But the fact remains that when such kind of strong images are roaming around in the media, and when it comes down to geosynthetics, there is always a negative connotation with it that talks about plastics in construction. So when we are again talking about plastics in construction, there's a range of types of polymers that gets used, and a range of application: pipes, pipe fittings, floorings, claddings, insulation, roofing. So there is a range of material already being available, and we are talking about recycling in a big way. So when we are talking about recycling and we are talking about geotextiles, somewhere down the line, again, there are two schools of thoughts out here. Because the premise of geosynthetics always was on the basis of virgin polymers. But in today's scenario, yes, we are using a range of recycled content also in geotextiles. So if you even look into the statistics in India, and these are a few-year-old statistics, but there has been a slight more skew in the current data, but not much. We see that, if you really look into the percentage of it, how is the plastic being consumed in the country? and I'm sure globally it is similar kind of percentages we are talking about, not just in terms of application, but also in terms of the kind of polymers we are talking about. And why I'm talking in these terms is basically because when we are talking about circular economy or we are talking about recycling of polymers for geosynthetic applications, we need to know what kind of percentage are we talking about, what is recyclable and what is not recyclable. And when I'm saying recyclable or not, I'm talking in terms of scaling and multiplicity, and not in terms of just research. Because research at the end of the day has to be aligned to what the industry needs, and the scaling becomes a very big factor in that. So when we look into recycling and polymers as such, this is the kind of material classification that is existing in the country, and this is what is coming back into the economy for production of other geosynthetic material. When it comes down to geosynthetics per se, the market is increasing many folds. There are very clear-cut statistics in the production capacity of the country. We are doing beautifully. We are one of the net exporters of geosynthetic material, well classified. The drivers are good. There is a very high awareness of PET and rPET, the difference between the two. So technical base and knowledge base is definitely high, and if you really look at the projection, where we have been working a lot, the projection between 20. I didn't ignite so much, did I? I said I'll stir the pot, but not to this extent. So anyway, so looking into these kind of material statistics, what we see is when it comes down to geotextiles, it is not just a market which is kilo-based or in dollar-based, but it is an application-based industry. So when we are talking about geosynthetics, it's not that we are producing so many tons of polymers and converting it into geotextile. What is also important and necessary to look into is what are the applications we are talking about. And when we talk about these two parameters on the same platform, that circularity of the plastics and usage, this is where the differentiation comes in terms of metrics. Because when you're talking about sustainability and indicators and metrics, geosynthetics is not a product that is material-based. It is a product which is typically designed on the basis of functions. So functionality of it invariably comes into the picture. So when we talk about a good cost-benefit analysis or a life cycle analysis, what we are talking about, what does it do? So one needs to dematerialize as much as possible when we are talking about deriving the metrics, especially in terms of recycling, because for instance, if I'm talking about a non-woven geotextile, one of the simplest basic products, and I'm talking about, say, a product for a particular, application like separation, typically the language that is very often used is use a 500 GSM textile. Now, this can be one of the worst specifications possible. The reason being, grammage cannot decide the specification of the product. It is the polymer, it is the function, and it is the properties of the product. Now, if I produce a 500 GSM geotextile with a recycled product or a recycled fiber, that does not give me the same functions as a virgin material. So when it comes down to actual comparison and actually calculating the durability factors and the carbon embodied, C we are talking about, unless we bring it down to the application range, we will not be comparing apple to apple. So what happens is this, the concept has to move away from being a material. So a 500 grams material, comparing to PET 500 GSM is not enough. So the functions of the product in terms of where it is being used is an essential commodity. So when we are defining the metrics for these kind of applications, we will have to move away from material, introduce the function part of it, and then get into redefining the metrics that we are talking about. So in a conclusion and way forward, all I can say is recycling, unfortunately, does not make any exception in needs of, for the product as such, in terms of its usage. So more the use of recycled material for production. A lot of it is possible. A lot of it is being done in the country already. We have some of the extremely good recycled content material, but what needs to be controlled is where it is to be used and where it is not. So again, I'm talking in terms of policy interventions, very clear-cut demarcations as to which are the applications where this is very nice to go ahead with, which are protected, which are not exposed to the UV and other elements, which has minimum potential of leaching into the environment and creating any possible potential of microplastics. Instead, those are the places probably we will have to target, but unless we segregate and put it as a document, as a policy matter, it would always be subject to misuse. So with those as the basics, we would look forward to this community taking this discussion forward so that mainstream material recycled can find proper usage in a more technical manner. Thank you so much.
Thank you so much, Sejal. I really appreciate it. I think you gave us circular economy, just like circular plastic reuse. That's interesting. I have some things later we'll share.
Sure.
I really like the pictures where you showed all the ecology. We were creating a kind of a novel product, we thought. Almost about to put, this is like a mangroves, artificial mangroves, the plastics. We're about to put it. Last thing is like environmental regulatory agency, they stopped it because they said, what if a fish get caught in between them? And that's going to kill a lot of fish over there. So we had to completely redo the whole work. And I think,
We have been working on that application a lot with natural geotextiles.
Yours is
Polymer modified, coil. So marshlands especially is a big thing for India.
The durability sometimes is a question there, but that is one thing. But I think overall is wonderful.
in my pen drive.
I think I will take a minute.
Which one?
Three great, excellent back-to-back. I really enjoyed your talk, Madhavi. I really want to say it's fantastic. I mean, I do work with 3D printing, but what you are doing with plastics is amazing. I want to introduce a good friend of ours, Vice President Shao, Dr. Shao. He's a member of TC307. He's very big help for us to start our honor lecture. And again, I was just going to give him maybe some 1 minute remarks or 2 minutes. Is up to you.
I think this group is amazing. You did a good job. I'm happy to make this TC event here possible. I believe you enjoyed the meeting very much until now, right? I hope that we can have a good communication and have a good development in the near future. Thank you.
Appreciate that. Thanks so much. Now let me introduce the person who did all the hard work here. Dr. Akanksha Tyagi is Associate Professor from Civil Engineering Department, IIT Roorkee. I just want to say before I give it to her, I just requested, I really wanted one of the young members to help with this workshop. I mean, it's a little bit challenging. I'm trying to engage the local folks, like in Portugal, I do the same thing. And I gave it to her, a little bit task, and Ramu also, and they both took a great job. They made my life easy, trust me, okay? They recruited all the speakers, and a fantastic job. So, over to you.
So, thank you for this opportunity. And so I'll be presenting today on the use of industrial waste for in situ ground improvement techniques, and later on a very brief topic which we worked on, use of waste material for road construction. So let us first understand what is in situ ground improvement. Basically, we are trying to add the binder in the in situ soil with the help of equipment, and we can have different techniques for that, like deep soil mixing. Deep soil mixing, wherein the binder slurry is mixed with the help of cutting and mixing tools within the ground to make soil cement columns. And jet grouting technology, wherein we are mixing the binder slurry to make again soil cement columns, but these soil cement columns can be vertical, inclined, horizontal. In the case of jet grouting, we are using high pressure nozzles to cut the soil and mix the admixture. While in deep soil mixing, we are using very low or negligible pressure. And with the help of mixing tools, basically we are adding the slurry. Another technique is mass soil stabilization, wherein we are creating blocks of stabilized region.
And it is usually used for peaty soils or contaminated ponds, wherein we are adding lots of cement to these region and making it basically reusable for construction point of view or for stabilization point of view. Now the point here is most of the countries, cold countries, Scandinavian countries, and in USA also, in South Asian countries, we are using all of these methods. In India also, we have used jet grouting in Tista project, in NTPC coal dam project, in Polavaram dam project. Most of us are using cement. And very less projects we are using GGBFS, or I have not seen any like more projects with fly ash. Most of us are using basically like OPC or either PPC. Like as Prof. Lee mentioned in his keynote lecture, usually the criteria is the minimum strength criteria. However, if we look at the applications, now if you look at the applications, this jet grouting or deep soil mixing are being used to create cut-off walls in dam projects for the construction as well as rehabilitation of the dams. They are also being used as vertical barriers for contaminated soils. They are being used for low permeable clay cement backfills for nuclear waste and also for tunnel stability. In some of the projects, hydraulic conductivity is also a very important parameter. Besides the strength, usually for such vertical barriers or seepage cutoff walls, we are looking at hydraulic conductivity is less than 1 into 10 to the power minus 8 meter per second, and strength more than around like 500 kPa, especially because we are also looking at the stability point of view. So the strength is also required. Now, at our laboratory at IIT Roorkee, our focus is to use the industrial waste, such as look at fly ash or GGBFS, steel slag, replace the cement in such technologies, and to see whether we can use it for different kind of applications. So our focus is not only on the strength but also on the hydraulic conductivity. Now hydraulic conductivity is one parameter which is like usually they give in the specifications, but it is very difficult to measure in the laboratory and also in the field. So we came out with the hydraulic conductivity measurements using accelerated permeability triaxial system, and we developed some design charts for hydraulic conductivity UCS for different water binder ratios. Contractors are now using UCS and water binder ratios charts, but they don't have charts for hydraulic conductivity and UCS or water binder ratios. We are also looking at freezing thawing durability, because for Himalayan regions where they are having these hydropower electric projects, they are having extreme temperatures. So we also studied the freezing thawing durability, and also we studied the effect of confining stress, because these columns are basically going to be 30 to 40 meter deep. So effect of confining stress is also there. So this is the custom fabricated accelerated permeability triaxial system. Basically this is a, you can see one part of it is a simple static triaxial that you have in your labs. The big cell that you see over there is the permeability cell, where we can actually test 100 mm by 100 mm soil grouted sample, and we have here used 3 pressure volume controllers. 2 pressure volume controllers are basically used to provide hydraulic gradient, so that we can actually control the top pressure and the back pressure. So at different hydraulic gradients we can measure the permeability. Also we can have different confining stresses. So at different confining stresses also we can measure the permeability of the grouted samples. We were able to measure the permeabilities of up to 10 to the power minus 11 meter per second in just 2 or 3 hours. But we would require it to saturate and consolidate, saturate, and then measure the permeability. It's very much similar to the flexi wall permeameter system, but it's custom fabricated for the diameter and the height, because usually grouted samples you wish to measure samples of higher like bigger dimensions. So now these results I would like to discuss. You can see over here, this is the untreated clay permeability. Now to a common person notion, people would think that if I add cement to clay, the permeability would decrease. But no, actually it usually doesn't happen. It was an elite clay, and because of the excessive calcium which is present in the cement, because of the cation exchange process, flocculated structures they are formed, and this
also been seen for Singapore marine clay by NUS researchers. So actually instead of decreasing the permeability, we are increasing the permeability. The question may come to your mind, why I am using clay as a base? Because okay, clay has lower permeability, but there is a strength requirement also in these projects. So when we added 50% replacement of GGBFS, then you can see because GGBFS has also silica and alumina, so therefore we were able to have reduced permeabilities, and in fact with the 30% binder the permeability was quite less. So we came out with some relationships between the UCS and hydraulic conductivity for cement treated clay, for alkali activated fly ash cement treated like FCAA clay, and for cement GGBFS treated clay. And basically we also came out some design charts for permeability and water binder ratios, so that practitioners, for them it is easier to use the charts. And we are not restricting ourselves to only clays, but now the students are also working on different soils so that we can have different charts which can be used by the practitioners. So the important takeaways are, if we have to go for a cut-off wall or foundation systems or tunnel stability which requires lower permeability, hydraulic conductivity and higher strength, then you go for GGBFS. You can actually use GGBFS up to 50% replacements. However, if you have requirements of low hydraulic conductivity and lower strength requirements like 100 kPa or 300 kPa, you can also use fly ash. The results, which I didn't discuss because of the time constraint, is the durability. What we saw in the freezing thawing durability is fly ash was not performing well. The fly ash treated clay specimens, they were broken after 12 freezing thawing cycles. So fly ash is not a good material to be used in Himalayan regions. But for the Himalayan projects, we can still use GGBFS, or in the cold countries, fly ash is not a good material to replace cement. So the second topic which I would like to share is the utilization of phosphogypsum. And this is a byproduct of phosphoric acid industries. And this is earlier work was also of my PhD student. This is also the work of my PhD student, Dr. Yatesh Thakur. And I remember I discussed this topic with Prof. Propala I think 3-4 years ago. And actually he said that, the main problem with this material is the high sulfate content. And he said, you are going to use that for the road. Now that contradicts our research. And actually that was a very important point, and we tried to take care that, that point in our thesis. So basically the point here is that this phosphogypsum material, it is being produced in million tons per year. And it is having heavy metals, it is having radionuclides. So usually it is stockpiled in the countries, and it is not being used because of the radionuclides presence in this phosphogypsum. They cannot be used for construction materials inside the building, but it can be used outside. So some of it is being used by agriculture industry, but not much, and still it is being stockpiled. Now since raw phosphogypsum, it is being, it can go to direct human exposure, can go to the lakes, rivers, so it is actually very much harmful to the environment. Now, these are the major challenges. As first one, I said high sulfate content, and it can cause heave-related distress in pavements, as discussed by Prof. Pupala in his lecture. Sulfate reaction with lime leads to expansion and crack formation, and low pH, it is very acidic. So that is another point why raw phosphogypsum cannot be used. Leaching and radioactivity concerns, high water absorption capacity. And there are differences in the European and the US regulations as far as the usage of this phosphogypsum is concerned. So basically we did a very extensive experimental study wherein we used phosphogypsum with fly ash. We also used phosphogypsum fly ash and lime, and phosphogypsum fly ash and NaOH. we use these combinations, and we didn't focus only on the mechanical performance like UCS, CBR, which are usually done by the researchers. We also saw what is the like resilient modulus, because we were looking at the road construction. We looked at the durability. What is the wetting drying durability? Water absorption. We looked at the mineralogical characteristics and environmental performance, which was very important in this case for coming out with guidelines for using this kind of material in actual road construction. So we used TCLP test, modified TCLP test for different pH, and we also did the radiological measurement. We didn't have the facility at IIT Roorkee, but we used the IUAC facility at New Delhi. So I don't have the time to go to all the results, but finally, just I would like to discuss the conclusions that we had. So if we talk about mechanical performance, it was okay. Like UCS, CBR, if you see, all the tested mixes were fine. And for the sub-base, usually PGFA and PGFA2 lime, like 2% lime, NaOH mixtures were fine. But in the durability, we saw only these mixtures, like which were having lime and NaOH, they passed the durability test. And if we talk about the repeated load cycles, then actually NaOH didn't perform much. And for subgrade, PGFA qualified with more than 40% PG, and for subbase, we with the 2% lime, those mixtures, they qualified for subbase. And if we look at the environmental criteria, which was very important, we saw that when we use this stabilized PG mixtures, then usually the heavy metals were in control limits, except the antimony, which was outside the non-hazardous but within the inert limits, EU limits. And we also checked the radioactivity. Radioactivity was also within the limits as being prescribed by AERB. And we also tested the sulfate leaching, which was important. So we found that for the mixtures, usually it was low expansion or safe, and when we used lime and 68 PG 30 FA, it was low to moderate expansion. So with this, basically with this kind of experimentation, we think that now we will move forwards to creating some kind of guidelines of a safe usage of phosphogypsum in the industries. So these are the publications. If any of your students are interested, this is my research group, which the 2 of them already completed and the 2 of them are still doing. Thank you very much.
Yeah, good afternoon. I'm really thankful for Professor Puppala for giving me this opportunity, and for Akanksha for coordinating this. And today I will discuss about the minimizing the cost and reducing the natural minerals for highway purposes using geosynthetics. Certain field tests we have done, and I think it will be interesting for some scholars here. So my presentation will flow in towards the understanding of the scholars. I know that you are all aware of it. I would like to thank some of the people here. I have fantastic students I have got from one BTech student and one is a doctoral scholar. They really worked hard for some of the topics here, and I would like to thank our previous alumni, IIT Hyderabad professors and supervisors. Some of the content is taken from them. I should acknowledge them in that direction. So some of the brief content I will discuss about what I have done for this geosynthetics in real field conditions, how we have evaluated and their outcomes. So without any further delay, so as we all know, everybody has focused on the sustainability importance, especially Professor Puppala has focused from cradle to grave, how all the stages can be considered for sustainability, and even Professor Madhavilata has spoke, Babu sir has spoke about all these things. I think I will skip here. As we all know that now India stands number 1 in the road network, 6.671 million kilometer. Previously we are in the second, USA was in the first, so now we have overclimbed in 2024. The upgradation has come and now we are in the first road network. Even if you take the entire road network of our Indian itself, it can circumference entire earth by 177 times. That means enormous resource is going on that. At the same time we are worried about the carbon emissions. So this is a true concern, and if you can even see that report published by IEA, nearly the transportation sector consumes 23% 40% of carbon emissions. Here I would like to point out for a scholar point of view, why the carbon emissions we are considering it more is because we know the reason. See, the major carbon emissions are carbon dioxide, methane and nitrous oxide. The carbon dioxide, once it goes into the atmosphere, it will entrap in the atmosphere and it will stay for 1,000 years, carbon dioxide itself. Methane, it will stay for 12 years, but more dangerous than the carbon dioxide. And the nitrous oxide, it will stay for 100 years also, but it is 300 times dangerous than the carbon dioxide. That's why we take equivalent as a carbon dioxide as a basis to compute all of them. So I think this will be helpful when I go further. Okay. I think. Yeah. Some statistics. Presently, we are building a road network at 28.3 kilometer, approximately 28 kilometers per day. For example, if I take any soft soil condition, and if you see all the pavement layers, nearly we required 371 million tons per annum at this rate of construction in India. So if it is required that much, and typical truck in our country carries in the practice 30 ton of material. So if it requires 12.4 million tons of trucks to transport this material. That's from the source to destination. So huge carbon emissions are going to be considered for this transportation sector itself. There is a concern that how we can reduce that through the geosynthetics. Whenever you see this kind of soft soils present, and it becomes more concern by increasing the thickness, we need to do a lot of stabilization works. So there it comes geosynthetics. For the scholars, I just gathered some literature there. 3,500 years ago in Mesopotamians, they used the reed mats in the temple construction. So this is of backs to the world in organic material they used. In Indian context, of course, we have used these reed mats for sleeping purpose and some other purposes. It dates back way before then. Dr. Brain in 1978 come up with the biaxial geogrids, and then uniaxial geogrids in 1980, and followed by triaxial, hexagonal, and so on. This multi-directional has come because especially for highways, when we speak about the stresses are random instead of in a bidirectional, then people have come with triaxial and then hexagonal and so on and so forth. So there is a good improvement, like Professor Madhav has mentioned. There is a works are coming up in geogrid technologies. So I will skip this state-of-art facility, starting from the Roman roads, where we had a 2-meter thickness up to, and then we have a very modern roads, very thin road sections, and several research scholars have quantified their mechanisms, service life, rutting prevention, and so on. But in reality, in the field, there are some people who worked extensively, and we are in that direction to quantify its design input, especially mechanistic input, so-called elastic modulus or resilient modulus in the field. How to evaluate that? There is a scope for that. So this generally, the geosynthetic benefit generally in the field, real field application can be incorporated through these three terms. One is traffic benefit ratio or layer coefficient ratio or the modulus improvement factor. These three are non-dimensional parameters obtained, and they have a certain range for each of them. And mostly in the industry, in the now practice, in IRC SP 59, there is a dedicated codal guidelines in IRC 37, which uses these modulus values directly into the design. And there are many projects have come up utilizing these things. So I will speak about why TBR, traffic benefit ratio, is not that much appreciated well. And it is based on the number of cycles observed for the unreinforced and reinforced. These are based on the classic elastic theories to compute. So some of the studies we have conducted at IIT Hyderabad, nearly about 140 plus large-scale test work we have conducted, and we have seen even hysteresis loops for unreinforced and reinforced. Even at 10 cycles, the reinforcement mechanism was able to pick up. That is an interlocking, membrane support, or bearing capacity. These are the excellent responses we have obtained through hysteresis loop. And typically for geocells also we have observed for different height of geocells, and the different mechanism is been observed in that direction. So for a geogrids, we have quantified a certain design parameters in the laboratory scale. However, there is some boundary conditions, so that we thought of exploring it for the field level also. In the geocell also, we have conducted for traffic benefit ratio, layer coefficient ratios, even the load spread angles, how much it can able to do. For geocells who are able to spread the load up to by 12 degrees at a maximum case and very favorable conditions. So these ranges have done, and even Professor Madhav has done a lot of work in the geocells. I think it's in a
classical work they have done in the mechanism. We're trying to do some field test as well as. And here comes a cyclic test. Under cyclic test, we want to evaluate the traffic benefit ratio, how this is coming and all, because it is directly used in an input design parameter. My two students have fabricated this cyclic plate load test. Actually, initially we are thinking of that it may go very high cost and all. In 4.5 lakhs, inclusive of GST, they are able to come up with this equipment by their own, with a small input from the industry people helping us. So this test is used for one hertz frequency. Under up to 40 kN we can upload 4 tons as per the IRC design guidelines. So these are some results we have obtained for permanent deformations versus number of cycles. For typically for any pavement design we do it for 2 inch of thickness or 20 mm rod depth. But in field it become very difficult to achieve that 20 mm rod depth. Some of the tests for a high subgrade conditions, very steep soils, we have ended up around 5 mm rod depth. For a low subgrade conditions, soft soils, we have ended up around 5 mm rod depth. And this become a very challenging to compute a 20 mm. So after 3 days of continuous work, we have stopped it and we have taken a really close value of at 10 mm rod depth to compute the traffic benefit ratios. So that's what I have mentioned in the earlier presentation, that it may not be appropriate to take rod depth at an half 1 inch so-called. And we have also come up with the traffic benefit ratios for a different subgrade conditions, including soft, medium and stiff conditions. And we have found that as the reinforcement stiffness is increasing, the better values are coming up, but it is up to our decision whether to use that value really in the field, because all other parameters we will be neglecting through the traffic benefit ratio. So one of our BTP student also performed this computational FEM analysis by keeping a different stiffnesses. So I'll briefly explain here. These are the plots on the left side shows the settlement versus bearing pressure. For a low subgrade conditions, the geosynthetics are performing better with the different stiffnesses. I would say up to 1200 kilonewton per meter axial stiffness, they're giving better in a lower subgrade condition. Where it goes to the stiff, so the geosynthetic becomes stiffer and stiffer as we increase the axial stiffness. The benefit is coming to be very low. Similarly, the stress and displacement and contours as shown. And in this direction, she also worked in MIF and carbon footprint estimation. Only for the production of the aggregate, we have observed up to 23% of the carbon emissions can be brought down. So in this line, we have also conducted some more experimental results for low, medium and stiff condition in the laboratory, and the same thing we have replicated in the field for one such condition. So this is the field procedures we have followed by taking a 100 meter stretch at several locations. And we have used a simple, even a static based plate load test to evaluate the modulus value. It's a simple equipment that we have 40 tons of load on a truck, and then we will be applying maximum of 10 ton using the static actuator that could quantify our results. So I'll quickly go for this carbon footprint estimation. For a field to give us some confidence for the people. So we have come up with this IRC, this conventional payment designs. You can consider it for ASTO also. They will fall in the same direction. So what we have done, activity multiplied with a carbon emission factor will give you the carbon calculations. We have computed in terms of kg CO2 equivalent per meter square. So because that's how the road network goes here. So for example, if you see IRC conventional payment, generally they are on the safer side, very conservative side. So that 47 to 37 for equivalent unstabilized section we have found. When you use the polypropylene based, that is a rigged geogrids, and we have a PET, that's a flexible payment, geogrids with higher stiffness, different carbon emissions were observed. Even for through the rutting also, we can calculate some carbon emissions for a flexible payment of higher MSA. And there is a classic paper by Suku and Professor Babu, and I think 17. And we are using that paper sometime for calculating this carbon footprint also as a basis, because they have predicted the n number of cycles also. So similarly, we have seen for higher subgrade conditions how the carbon footprints are seen. And I would say that when you use this geosynthetics, at least 15% from cradle to grave, we can reduce the carbon emissions. That is what we have felt. There are several stages, the sourcing, then placing, transportation, diesel consumption, everything is there. So the overall, I would like to say that per lane, 3.75 meter, 1 kilometer, if you're using this different types of geosynthetics, I think you can go up to, in ideal case, you can go up to 70 lakh reduction in a 1 kilometer length. This is a huge business for even contractors. They are always worried about the cost reductions. When we provide this kind of solution, it's always helpful for them. So such a projects we have done more than 50 around different states of country, whenever required for evolution, all these things. So my student is working on this completely on those things. So I think I will end up here. I took about enough time. I think I should go. So modulus improvement factor are the layer coefficient ratio. They are the best to use in the design. Traffic benefit ratio is still we are working on that. It may take some time to incorporating into the system. Right now they are using it in IRC special publication. In future we should also consider the cost and then carbon emissions. I think this would make a clear guideline for upgrading the amendments. So I think with this, I would like to thank again Professor Anand Puppala for giving me this opportunity and all the colleagues. And I can see the torch bearers here, some of them. I hope this is helpful somewhere. Thank you so much.
Thank you so much, Dr. Ramu. Now I would like to invite Dr. Sayantan Chakrabarty for his presentation. And after Dr. Sayantan Chakrabarty, we have the last presentation by Dr. Surya Congress.
Excuse me. जो पावर पॉइंट में किया था Okay, good evening everyone. So before I begin, I would like to thank Dr. Puppala. Yeah. So thank you, Professor Puppala, and thank you, Professor Tyagi, for giving me the opportunity to present some of the work we are doing at PITS Pilani. So the topic of the presentation is stabilization of high sulfate soils using lime and quarry dust. So this is based on an ongoing project which my PhD student is working on, Ajay Mukherjee. So the project was funded by SERB. It's a part of the Startup Research Grant. So this will be the presentation outline, starting with the introduction and background, objectives, materials methodology. I'll be showing some of the results and then concluding. So as we all know that performance of any civil engineering infrastructure, it will be depending on the engineering properties of the underlying soil which is present. If we encounter problematic soil, typically it's treated with traditional calcium-based stabilizers like lime, cement, fly ash, or a combination of this. Now, whenever we go for treatment of the soil, we will be seeing improvement in engineering properties like strength improvement will be there, stiffness will be increasing, workability, durability. Plus, we will be seeing benefits in terms of reduction in water affinity, and the swell strength potential will also be going down. However, this kind of calcium-based stabilizer, it's not suitable for soils which are having sulfates, specifically because of formation of two pretty expensive minerals, the ettringite and thaumasite. So ettringite, it's an expensive calcium aluminate sulfate hydrate mineral, and the extent of ettringite induced damage, it will be depending on several parameters. Some of the parameters are mentioned here, like clay mineralogy, pH of the system, the curing period, what's the sulfate content, what's the temperature conditions, and so on. So current state of the practice, it recommends that don't use calcium-based stabilizer if you are having sulfate content more than 8000 ppm. Typically, the remedial measures will be like precompaction mellowing, a double lime treatment, using low calcium or even no calcium stabilizer, or even co-additives like fly ash or GGBFS, those are used frequently, which serves as some kind of source of amorphous silica. So that's why a few questions came to our mind that instead of using amorphous silica, can we think about using some kind of crystalline silica phases? Will the crystalline silica be just remaining as inert material, or will it be participating in chemical reaction? So quarry dust, which has got crystalline silica, we wanted to check whether it can be used as a co-additive with calcium-based stabilizer. So quarry dust, it's a waste product which is generated during rock crushing process. It's a waste product which is rich in crystalline silica, not the amorphous one. So millions of tons of quarry dust are available and generated worldwide. So if we are able to use this kind of product, it's expected that it will be beneficial for transportation engineers or even geotechnical engineers. So that's why we are trying to address this question, that could we use quarry dust for mitigating ettringite-induced heaving by using it as a co-additive. So we are trying to address three main objectives. First of all, we are trying to explore the scope of utilizing quarry dust for mitigating ettringite-induced heaving, to check if quarry dust can participate in chemical reaction or it will be remaining as an inert material only. And lastly, we want to find out what's the underlying reason behind the observed changes in engineering behavior. So coming to the materials and methodology part, the soil that we are using, the test soil, it's a manufactured soil having 30% bentonite and 70% sand. So the basic soil characterization test results are shown here. So if you look at the PI value, the 1D free soil strain, and the percentage strength loss after moisture exposure. So looking at these values, it's pretty obvious that the soil is a problematic soil and it is suitable for lime stabilization. So for this soil mixture, we are using lime as the stabilizer. We found out the optimum lime content using the Idzen-Grimm pH test. So this is the first group which we are considering, the LS, that is simply the lime treated soil, no sulfate, nothing. Okay. The next group that we are considering is the LHS, which is the lime-treated high-sulfate soil. So what we are doing is, to this soil mixture, we are artificially adding gypsum and spiking the sulfate content to 20,000 ppm, which is pretty high sulfate range. So that will be the second group, the LHS. And the last group which we are considering, that is the LHS 30QD, that is this soil mixture, the sulfate content increased using gypsum. On top of that, we are using Quadifines as the co-additive. So for these three groups, we prepared cylindrical specimens for strength testing as well as swell testing. So the samples were cured in a temperature controlled humidity chamber, and after different curing periods, here I am showing the data for only 2 curing periods, 3 days and 28 days. 3 days corresponding to short curing period, 20 days corresponding to relatively longer curing period. So after curing, we performed the UCS test on the specimens, and for another set, what we did is we subjected the specimens to capillary soaking, moisture exposure, and then we performed the testing. So besides strength testing, we also performed the 1D free swell strain to figure out how much is the swelling characteristics. So this is about the engineering testing. So we wanted to find out what's the underlying reason behind the observed behavior. So that's why we performed mineralogical and microstructural studies as well. So the treated soil, we sieved it through 75 micron sieve. Then the fraction which was passing 75 micron, we performed DTA, TGA, XRD and SEM analysis on these soil specimens. So coming to the results part, so at first I will be presenting the result for strength testing, and then I will be showing the result for the swell testing. So a couple of graphs are shown here. The left one for the lime treated soil, no sulfate, and the right one lime treated high sulfate soil, which is having 20,000 ppm of sulfate. The data is providing information about the strength before capillary soaking, after capillary soaking, and also the soaked volume. That means after soaking, how much was the volume. So for the lime treated soil, as expected, the strength increased with curing time, and that's because of the cementitious products which are forming. After moisture exposure, the strength loss took place, but the extent of strength loss went down with an increase in curing period. So this is something pretty obvious and expected. Now if you look at the lime treated high sulfate soil results, so you will see significant amount of strength loss, and that is like 89% strength loss even after 28 days of curing. And if you compare the volume of the specimen after soaking as compared to the no sulfate soil, for the high sulfate soil you will see there is a significant amount of swelling which is going on. The volume of the specimen is pretty high. So this result actually shows the problem of treating high sulfate soil with lime. So some kind of expansive mineral is forming inside. So here we are comparing the lime-treated high sulfate soil strength and volume result with the one in which the quarry dust was also used. So if you look at the lime-treated high sulfate soil with quarry dust, after 28 days curing, you will see that the strength loss has gone down significantly. And at the same time, if you look at the volume result as compared to the lime-treated high sulfate soil, the volume of the specimen is also significantly low after capillary soaking. So this is showing you the improvement on introducing this kind of waste material like the quarry dust. The thing is, for 3 days curing, not significant amount of improvement is observed. That's because, after all, quarry dust is having crystalline silica. It's not having amorphous silica as such. So that's why it will be taking some curing period for it to come into the reaction. Next, let's look at the swell test result. So this is showing you the graph of 1D free swell strain versus the elapsed time, the duration for which it was submerged in water. The graph to the left, it's showing the data for 3 days cured specimen. The graph to the right, it's showing for 28 days cured specimen. So for the 3 days cured specimen, for the lime-treated high sulfate soil, you can see this characteristics S-shaped curve, which shows that ettringite is forming inside the specimen. A 7% 1D free swell strain even after lime treatment, which shows that lime treatment is ineffective in this case. When we introduced quarry fines, the swell strain went down significantly. And again, it's just 3 days curing, so it's not expected to be significantly participating in the chemical reaction. For the 28 days one, we can see that the swelling itself went down, and that's because in 28 days, cementitious reaction products are forming. It's binding the matrix together, and that way it's preventing the swelling to some extent. So here also we can see that the quarry dust specimen performed well as compared to the one which is having just high sulfate. Next, we tried to figure out what's the underlying reason behind the observed behavior. So here the X-ray diffraction results are shown. This one is showing for the lime-treated high sulfate soil, and this one is with quarry fines. So in the lime-treated high sulfate soil, you will see the ettringite peaks are visible, and it's because of these ettringite crystals that you are able to see that significant amount of damage which was shown in the earlier slides. Whereas for the one which is having quarry dust, you can see that the ettringite peak is either gone or the intensity is significantly low. So this basically shows that this quarry dust, which is a waste product, it has got potential to suppress the ettringite formation, at least partially for sure. Next here it shows the FESEM images. The one to the left, this one shows for lime-treated high sulfate soil. So these elongated crystals that you are able to see, so these are basically the ettringite crystals. We performed EDX as well, in that we saw that Ca, Al and S, those are the predominant elements which were present, which kind of proved that ettringite was the cause of the damage which was shown earlier. The figure to the right, this one shows for LHS with 30% quarry dust. Here also you can see the ettringite crystals are there, but one more additional parameter is there, that if you look closely, CSH gel is available, and it seems like that CSH gel is binding the soil much better. So that way the performance of this one was way better as compared to the performance of this one in terms of the strength and swelling characteristics. So next we tried to figure out that what exactly is happening because of which we are seeing the improvement on introducing quarry dust. So what we did is we took the quarry dust, we performed FESEM images of this quarry dust, and then we added lime to quarry dust, just lime treated quarry dust. So in the figure to the left you can see the quarry dust particles are there, the crystals that you are able to see. The figure to the right, this is after lime treatment, and in this one, so I hope you are able to see that on the quarry dust particles there is some amorphous product which has formed. So these are basically the CSH phases which has coated the quarry dust particle. So we performed EDX on this one as well, and we were able to see that these amorphous phases were actually CSH. So we were able to see Ca and Si which are present. So that way we can consider here that the silica which is present in the quarry dust, it definitely reacted with lime to form some CSH, the cementitious product. So without just relying on SEM, we also performed X-ray diffraction. So this is showing you the XRD diffractogram for quarry dust, and this is lime treated quarry dust. Here also I hope you are able to see two small new peaks came up which were not present here. So these peaks are corresponding to CSH. So CSH which is formed in room temperature condition, it's not expected to be crystalline, and that's the reason why the intensity of the peaks are low. but irrespective of that, you can see some new peaks are forming no matter what. And in the right, TGA data is shown for quarry dust and lime-treated quarry dust. So let's say if the quarry dust was not participating in chemical reaction, then what we would have expected to see is the pattern would have looked similar to the quarry dust with two different changes. One is there would have been a drop here around 400 degrees centigrade because of dehydration of lime, and then there would have been another drop here because of the decarbonation of calcite. Whereas if you see the lime treated quarry dust, the blue colored one, there are no peaks available here, no drop is taking place here around 400 or 450 degrees centigrade, so which shows that lime is not present here. So lime was actually used up in the chemical reaction. The other thing to note is typically the CSH phase, it will be losing water till 240 degrees centigrade. So here as compared to quarry dust, you can see that there is more wet loss in the lime treated quarry dust, so which shows that the wet loss which was taking place here, that's because of dehydration of water from the CSH phases. So this also proves that CSH was forming in the lime treated quarry dust. So this is the last slide, I will be wrapping up soon. Next we wanted to see that the CSH which is forming in the lime treated quarry dust, can it impart some strength properties? So we performed XRF of the quarry dust and we saw that there is a significant amount of silica which is present, 70.3% silica is there. So we performed UCS testing on the lime treated quarry dust. So if quarry dust was not participating in reaction, then with increase in curing period we wouldn't have seen any increase in strength. Whereas here you can see the 3-day strength is like 307 kPa, whereas after 28 days it increased to 941 kPa. So this proves that quarry dust definitely reacted with lime to form cementitious phases, which is basically the CSH which we had seen earlier. So coming to the conclusions, so we can see that calcium-based stabilizer definitely was ineffective for stabilizing sulfate-rich soil. Lots of swelling was there, lots of strength loss was there after exposure to moisture. When quarry dust was used with lime, there was a decrease in post-soaking strength. Swelling characteristics went down significantly. Regarding the cause behind the engineering behavior which was observed, so this ettringite, this was the main cause of trouble. The strength loss, swelling, everything took place because of this. And quarry dust, this was beneficial. It reduced the overall sulfate content and definitely reacted with lime to form some additional CSH phases. So finally we can conclude that this quarry fines, which is a waste material, it can be used as a sustainable admixture for treating soils which are having high sulfate content. Thank you.
Okay, thank you, Dr. Sayantan. Now I would like to invite Dr. Surya. So, for
You
his
can take
presentation,
that. Yeah, I'll
this is the
just-
last one because he wants to show some very interesting drone videos of his laptop. So he said that he will be going last.
Thank you. With the charger. Charging is there. I'll put it. Thank you. You can take your time. Okay. Now should I connect this audio? Audio is not here. Okay. Yeah, I can talk. Just adjust that. Yeah, it is. I think. Can I get the... Okay, good evening everyone. I know I'm in between the presentations and the gala, so I better do a good job so that it is worth your time to listen. So today I'm going to discuss about our research on using remote sensing and explainable AI to understand the landslide susceptibility in Minnesota, USA. And this is the presentation outline. I will be discussing the landslide susceptibility mapping, study objectives as well as the area that we considered, and I'll be discussing more on the methodology as well briefly, how we are integrating TabNet and SHAP, and the modeling results as well as field validation using drones, and then I'll conclude with my observations. So, you might be familiar with slope instability. I see one person who was there at the previous session as well, so I might be boring, so please ignore. So, slope instability is a widespread geological hazard, often manifests as landslides when large soil or rock mass fails. How do they fail? There are multiple triggering mechanisms like the rainfall or seismic activity cause the shear stress to exceed the shear strength. That is how these landslides occur. And they cause significant damage to the infrastructure as well as to cause loss of lives. And this is one of the landslides captured in Minnesota. As you can see this. How many of you have attended the Geo Congress in 2022 or 2021 or 2020? When was COVID? Before COVID shut everything down, we had a Geo Congress in Minneapolis. So if you have attended, that's the same area that we are talking about here. So in regions like Minnesota, landslides have historically led to considerable economic losses, and they cause millions of dollars in annual repairs. So we need to prioritize those high-risk areas. Why? Because we have only limited resources, so we want to prioritize and make informed decisions. So for that, we need to conduct landslide susceptibility mapping so that it reflects the likelihood of landslide occurring as well. So in the previous studies, typically GIS and statistical models are integrated together to come up with this modeling. And in our study, we'll be using a deep neural network model to arrive at this landslide susceptibility map. So these are the objectives. The first one is we model the landslide susceptibility using TabNet, which is a type of deep neural network model. And then we develop a high resolution map where you can see which locations are susceptible and which locations are not. How is it useful? These departments of transportation agencies can actually see if there is a highway passing through, or even other agencies like FEMA and all see if there is a zone where there are schools or some other critical communities lying, and then we can make informed decisions in relocating them or rehabilitating those areas. And one additional thing that I will emphasize in our study is validating the results. Because when I say validating results, how many of you do modeling? Okay. When I say validating results, you might think, okay, 70% split and 30% validation. That comes under this modeling already. But when I'm saying validation, we did an independent validation where we collected field data so that we can see whether the modeling results that gave are matching with the actual results. So that's something that I'll be showing, and thanks to Akanksha for allowing me to go at the last so that I can show those 2 to 3 GB videos, because it's not easy to transfer everywhere. So, and then the additional part that I want to emphasize is, how many of you have used machine learning before? Okay. And how many of you have thought, so if I see in the room a quick scan, there are a lot of stalwarts. Probably if you say that you haven't used machine learning, I can sense a reason. Why? Because those are called black box models. Dr. Lata, do you agree with that? So they're called black box models, and you don't know what it is spitting out. So that is one thing that I want to add here is, we are using machine learning models, but we are also adding it explainable AI techniques. So basically we are trying to make sense of this black box. So that is something that I'll highlight in my study as well. So this is Minnesota map here. This is US map and this is Minnesota map. And Minnesota has a wide variety of geography as well as climate. So geographically, there are a lot of high pI clayey soils in this region.
and here some rocks and different types of soils. So with wide variety of soils, it has potential of landslides and also climatic factors. So when I say climatic factors, maybe being most parts of India, we might not connect with snow, but this region undergoes a wide range. In summers, it can go up till 35 to 40 Celsius. And in winters, it can go up to minus 40 or minus 30. When I say minus 40, I'm not even saying Fahrenheit or Celsius. Why? Because it doesn't matter. It's the same. Minus 40 is the same. So, and I can also vouch for it because I lived in there. Minus 40. I'm tested in both Indian plus 45 and Minnesota minus 45. So anyway, why am I even saying that? If the soil, same soil, is subjected to both extremes, then you'll see the cracking and desiccation behavior, and also I'll also show you the tension cracks that happen, especially if it is a high pH clay. So the methodology, we collected 7,000 points from various sources across Minnesota. And you can see this is the distribution of the landslide points. And then we created buffer zones around them and got the equal number of non-landslide points. So now we have 14,000 points. So 14,000 points were split into 70% and 30%, basically 70% for training and 30% for validation. And we collected 10 causative factors based upon the literature study. These are the 10 causative factors that were collected. And then before we even use it, since I saw a lot of audience have already done modeling, so we want to do multicollinearity analysis, right? So that's the first thing, to make sure they are interdependent or not. So what we did was we captured in terms of VIF factor, and again, this is just one of the several factors that we can use for evaluating multicollinearity. So we use this, and then as we speak, we are also working on a few other factors to evaluate it. But just to show you, we calculated VIF by calculating the coefficient of determination here, and this is the formula. But I would like to highlight, based on the literature, a VIF of less than 10 indicates independence between variables. So that's something that we noted. And then the TabNet architecture. So before I move on, I'm going to let you know, TabNet is a type of deep neural network model. So can anyone tell me, or let me ask you, are you familiar with deep neural network? How many of you are familiar? Okay. So others who may not be familiar, that you already know. Actually, you already know how a deep neural network works. But I will try to facilitate and help you understand what is deep neural network. So basically, deep neural network is something that simulates what we already have. So with that thought, let me go back to the basic. How many of you know an orange? Okay, that's a tough one. If someone says I don't know orange, then I need to maybe let's say apple. How many of you know an apple? I mean, okay, very good. How do you know an apple is an apple? Someone taught you, teachers or parents. So now the same learning technique, can we do it as us being the parents, the computer being the parent? So we feed the data by annotation and several processes, and then let the model learn from the features and all, and then in the future, when it sees the same apple or orange, it will spit out saying this is an orange or an apple based upon the brain. So it simulates the brain structure, like the neurons and all, to learn all those. So with that, I would like to mention that this is a specific deep neural network model, specifically tailored for tabular data. So, and this is the architecture, and again, I'm not going to go over in detail, but if you are interested, I'll be happy to talk after the presentation so that Akanksha will not drag me out of this podium. So, because of the time, I would like to highlight two feature layers, which are two layers, which is a feature transformer and attentive transformer. Those are the most important ones
that are helpful in this process. As you can see, feature transform layer actually helps in learning the representation of the input features. When we input features, it actually learns the representation of it and then passes on this information on to the attentive layer, which actually integrates an attention mechanism to pinpoint most relevant features. So for example, if you apply to the problem, apple or orange, one of the things that it will highlight on is relevant features for apple is the shape, the color, and different other things. So if you understand that, the next part is to model it. So when we model it, we use the validation accuracy to evaluate what are the hyperparameters that are needed. So we iteratively do it to actually calculate these hyperparameters, which I show in this slide. This is the end of those hypertuning, and we use this to calculate the modeling results. But let me show the first result is the multicollinearity analysis. So if you see all these causative factors, the VIF is less than probably around 1.5. What was the number that we discussed about so that they are considered to be independent? Very good. 10. See, you guys are my star performers in the class. So they are independent. Again, in the future we plan to use more. Did you say that too? Oh, 3 minutes? Okay, thank you. You're not my star performer. So if you see, we also had the confusion matrix. Out of those 30% for validation, if you see the true positive and true negative, just to show you what is true positive and true negative. So this is the true label. That means when we fed the data, the landslide is considered in this, and the prediction is also considered to be this. So both are true, that is true positive. That is 1992. And this one true negative is prediction is also non-landslide as well as true label. So if you can see, both of them are high, which gives us the confidence that the model did well. Again, I'm not emphasizing on the model, because in this presentation, I'm emphasizing much more beyond, which is explainable AI and the validation. So again, these are just numbers. Like I said, 0.96, it depends upon the points that we take and also consider. But what I want to emphasize is this. This is the map that we generated, and this is the distribution, and this is the explainable AI part. So if you see how the causative factors that cause this are actually giving us this plot. Because of the time, I'm going to explain briefly about the first one. If you see slope here, this color is low. So what does this mean here? If slope is lower, then this is on the negative side of the model output. What is the model output? Landslide, potential. So what it does say is, if the slope is on the lower end, then the impact or the landslide potential is decreasing. But if the slope is higher, if you see higher, then the landslide potential is going up. So this is the kind of analysis that we actually get. Okay. So yeah, I don't need it. So unless if someone in Mumbai wants to hear. So anyway, this is what we generated for the model. And then next is validation. If you see these sites at these locations, when we zoom in, we found it to be between medium to high potential of a landslide. So I'm going to show you an independent field investigation of these away from these modeling results. And this is the first one, climax site. So this is a news reporter reporting. Again, I mentioned there is high PI clay, right? This drop is 25 feet. The soil in this cornfield dropped up to 25 feet. And then, I'm sorry, probably it's because of my love for my eyes. I always put it under night light, so probably you'll see it better now. Okay, I'm so sorry that I always work under, let's see. Okay, now it's better, I guess? Okay, great. So, should I restart? Okay. Okay, thank you. So, if you see this side here, in August 2015, there is not much of slope failure. We collected historical data. But what you see next is September 22, you can see some cracks occurring. And again, this is all high PI clay subjected to freezing on thawing. So you can imagine that tension crack width, it is around 1 to 2 meters. So what is happening is because the soil is failing, it is actually tipping the piers like this, and the bridges are cracking. So we are doing an independent research for slope stability analysis as well, but this one is more geomorphological, but in the future we'll be doing a 3D slope stability analysis as well. But with that, let me show you a 3D model of that area. This is a model that we captured using drones. Why? Because Google Earth will give you half a meter, but this one, half a centimeter resolution. That is what helpful for us to understand these minute changes that are happening in the field so that we can correlate them. So you can see this, again, this is how it looks in winter, the snow and all. And now this in summer, you can see the same, but captured at a different time using the drones. You can see it's further deteriorating. And we are using this to do the slope stability. You can see the bridge pier somewhere here. So it's actually tipping. So that's one reason we got a project with Minnesota Department of Transportation where we are doing the slope stability analysis. But when we do slope stability analysis, as you are familiar, we need to use the bare earth point cloud. How do we get it? From the LiDAR. As you can see, this is LiDAR point cloud, which we'll use to get the bare earth and do the stability analysis. And moving on to the last one, you can see this is another highway near the Minneapolis airport. This is the highway, and this drop is around 100 feet. And in 2012, this used to be somewhere probably 20 feet away, but there was a landslide and 2 kids lost their lives because of the landslide. So that's one reason we are working with the Minnesota Department of Transportation. And you can see this home here. I was flying the drone from there to capture all this information. And currently we are working to do the slope stability analysis as well. So with that, I would like to conclude. We demonstrated the applications of remote sensing and deep neural networks for landslide susceptibility mapping. And then again, the validation accuracy is great, but what I want to emphasize is to do independent validation using field data. And then use an explainable AI where, okay, you are getting this result, why? So that we know if slope is the one that is causing higher failures, maybe we might need to do something about it, or water table, or rainfall, something else. So we understand the causative factors and their influence so that we can get a potential landslide susceptibility map so that we can help agencies in make informed decisions for sustainable infrastructure. Actually, I could leave the word sustainable and resilient in India, but when I enter US, I need to remove those words, especially now. So with that, I'll be happy to take any questions from you.
Sir, I have a small question about sharp interpretation.
Yes.
Sir, in that sharp explainable AI, sir, can you explain what is the significance of that sharp values like higher positive value or higher negative value? Is it explaining the like how much that causative factors is affecting the model, or how model is working? Like I want to understand about the significance of that sharp values.
That's a very good question. So you're talking about the x-axis values where there is 0, minus 0.2, minus 0.4.
Yeah.
So they don't have quantitative value, but it will let us know if it is 0 and then going to minus 0.2, minus 0.4. That means it says the landslide potential is decreasing as we go this side. But if it goes on the positive side, that means it is increasing. So it's more like unitless, but it will let us know if it is going from 0.2 for one causative factor to 0.4 to another causative factor. That means twice.
Explaining the magnitude, like how much it is affecting.
Yes.
Yeah.
Yes.
Okay, sir. And this sharp explainable AI, is it explaining only that how causative factors are helping to reach out at the output, or it's explaining that how our model is working? Like it's a...
That's a good question. In fact, I couldn't include the slide about SHAP. So it's based upon game theory.
Game theory, yes.
So how it works is you have, let's say, 3, X, Y, Z.
Okay.
So if you add X to already Y and Z, how the output is changing. So it will calculate it. And then again, if X is there and only Y is there, how it is changing. X, Y. So it calculates multiple iterations to give out that value.
based upon game-based theory. And there is also another, so I said sharp, right? That is only one way. There are also counterfactuals. So that actually gives idea about how much if we change, then the output will go down. For example, if I say slope is reduced by this, will it reduce the potential of landslide by this much? So if you are interested, please look into counterfactuals as well. And geotechnical, we don't use much of explainable AI because we leave it for granted most of the times, the variability and all. But right now, I feel as geotechnical engineers, we need to start adopting much more advanced techniques like this so that we can make sense of this black box model.
Okay. Thank you, sir. Thank you very much, Dr. Surya, and thank you for coming at the end, giving an excellent lecture, and we all woke up actually.
Oh, thank you.
It was literally eye-opening.
And I have to, I couldn't even acknowledge. In fact, I have to say this is the first conference where you guys took care of our health as well. Because of the concurrent sessions, I had to run from previous one to here, so I'm now more healthy. So I would like to acknowledge, Dr. Tyagi, Dr. Pupala, Dr. Joseph, Dr. Juneja, Dr. Murthy for giving us. Ashish. Yeah. For setting us here. Yeah. Thank you so much.
Thank you so much. And so we are now closing this session, and I hope we had a very it was not interactive because we are already close to 6. Engaging session. And I'm really thankful to the audience who are here up to late evening, because all of you must be awaiting for the gala dinner. And I would like to invite Professor G.L. Babu on the behalf of Geotech Asia. We would like to honor Professor Anand J. Pupala for chairing this session. No,
please. No, I already have 4. No, I think I want to give this to you. Please.
No. Your name is written.
No, I'm seriously, because I actually give you. Smile, just take it on. Honestly, guys, thank you so much. I wish I could give this to you. But I can tell you one thing. This is probably this is our third workshop, but this workshop is most brilliant. I totally agree with you. Very engaging and very stimulating. I'm actually going to see if you guys don't mind when we do the next 2 workshops. I'd like to invite some of you to see if you can get engaged either in Cambridge or in Portugal. There's some fantastic stuff like the 3D printing of your geosynthetics, and also your complete the way you're thinking of how to create better products. I mean, we deal with it every day, trust me. I mean, I'm just telling you, I had a big project for controlling the erosion. 80% of the work done. The last 20% I had to get the environmental regulatory approved. That's where I got stuck. Then I was sitting with hydraulics engineer on the dam. He said, hey, we can't do that because it's going to kill the fish out there. Here I am a geotech guy. I don't know the ecology part of it. I had a colleague, but I'm complete eye-opener, and I totally understood it because he doesn't want to create an issue for fishery folks living in that area. But I couldn't use it. I mean, the work is done well, it's working well, everything, but sometimes you cannot do it. So again, thank you for that kind of inspiration, and of course, Dr. Ganges, thank you for waking me up. I'm almost jet lagged, last half an hour I was struggling. I don't think he needs the mic. And again, Sayantani was my former student also. He's at BITS Pilani. Amazing work. Really he's continuing my sulfate research. I'm so thankful to see that. And again, you both really doing the whole thing. I really enjoyed the hospital himself and also on the roads. And he was telling me it's not funded. And he's doing amazing work in the field, testing it without funding. So, it's not an easy time for getting funding, but you guys work hard. I hope you'll get it. But again, I just want to say one thing. Always impressed with Professor Mahadina. She's wonderful. But this is my second time I'm listening to it. But the 3D printing, when she had that paper, I was amazed that paper, the AST development. I think we need to thank Akansha. Yeah, let's take a picture. Dr. Thank Akansha. She's the backbone of this.